we should convince the farmers to adopt the mechanical harvesters, because they are mostly reliable on the manpower harvesting. So is there any difference between cane harvesters and manpower harvesting? Please.
Any different how to convince the farmers for mechanical harvesting?
Okay. Okay.
Hello. Please come.
Wait,
We conveyed
Convince
But,
the farmers to use
how to convince.
Yeah.
How you are convincing?
the
How you are convincing farmers in your country? First.
use
Yeah. Yeah. Yeah.
Yeah, if I understand right, your question is how to convince the farmers to go to the mechanical harvesting, right? Yeah, I think it's a similar question in China. And the field is small in India and China similar. Also our mechanism, for example, the farmers need to make more money. Another audience have the question, what's the trash content about the mechanical harvesting? I said less than 5%. I think if the sugar can harvested manually, it's more clean. It's more cleaner. That means the farmers have a little bit less profit. Yeah, the farmers like to make money. So how to convince the farmers to use mechanical harvesting? That means if we calculate the whole cost, whole harvesting cost, I don't know exactly the harvesting cost in India, but in China, if you use machines for the sugarcane harvesting, the cost much less than by laborers. If you hire laborers do the harvesting, that means the farmers need to pay more money. So if you calculate the money you saved by mechanical harvesting minus the little bit you paid more for the profit, I think the farmer can still make more money. Yeah, thank you.
आंबेगावकर, चायनामध्ये कन्व्हिन्स करायची गोष्ट नसते, तिथंच आदेश येतो त्याप्रमाणे काम करायचं. एनिवे, प्लीज. Now last speaker of this session, Dr. V.M. Mayende sir, former Vice Chancellor of Dr. P.D.K. Vyakula, and he will present the status of sugarcane mechanization in India. Dr. Mayende sir. Before that, I think Dr. Shinde sir will give his brief introduction.
Dr. Mayende has his specialization in agriculture engineering, farm mechanization. He has more than 40 years experience. He has 11 patents. He published 115 papers. He received more than 6 awards, and he is a member of the several scientific bodies. I will request him to deliver the talk.
स्लाइड पुढे करायचं ते आहे ना स्लाइड समोर. Good afternoon, everyone. Mr. Chairman, all the panelists and distinguished participants of this conference. Dr. Ma has already mentioned about the sugarcane harvesting technology in China. I will be talking about the Indian situation where we are now. Now, the first question that comes to our mind that why we want to mechanize our sugarcane. I think the answer from all the audience and those who are working in sugarcane will be that we don't have a labor for operation. It's a very labor-intensive crop, and we have a scarcity of labor all along. So we need a machine to substitute labor. That's the answer. But apart from labor scarcity, there are many advantages of mechanization that we often forget about it. Number one is the cost of the operation, ease of the operation, comfort of the operation has to be improved, and that's where we need a mechanized sugarcane area. Another aspect is we want timely completion of operation. For example, harvesting cannot be delayed. You have to harvest timely. You need a machine. You also need a precision harvesting. Mr. Mai has mentioned that sensor controlled cutting machines. You have to perfectly cut the sugarcane crop at the bottom at different depth. So precision in all the operation is essential. Lastly, the drudgery in manual operation of sugarcane is very high. We need to have all operations in comfort. You do not have people to work under a drudgerous condition. And that's where we want to remove the drudgery and improve comfort in operation. Next, we need to have every work done in the field as a quality work. Overall quality of sugarcane growing, global competitiveness of the country. We are competing globally for sugarcane. Brazil is our competitor. And if we want to improve our quality of cane grown and ease of operation, reduce the cost of production of sugarcane and further processing, I think we can compete with other countries globally. So that's where we are looking for a mechanization in sugarcane area. Still, sugarcane cultivation is still, we are dependent on human labor. Almost 53% of the sugarcane cultivation is still dependent on human labor. I think we'll have to really substitute this labor, and that's where we need a mechanization. In mechanization, when we talk about mechanizing sugarcane cultivation, there are different operations that we do in sugarcane, right from tillage till harvesting and ratoon management. So in case of land preparation, I think by and large, we have mechanized our land preparation. We plow the land, we cultivate the land, we make the irrigation furrows. We have all the required machineries available in the country. Now 90 to 100% of land preparation operation is mechanized. I think absolutely there is no need of really doing any innovation as far as land preparation is concerned. Then we come to a sugarcane planting. In case of planting, we still go for a manual planting. We put the sets in the furrow and then irrigate them and then allow them to irrigate. It's a human agriculture, human dependent, labor dependent operation. We have some of the good efficient machinery available, including VSI has given a sugarcane shed cutting machinery, semi-automatic machinery for planting operation. There are some machineries which are available for planting of the sugarcane, transplanting of the sugarcane, where you have to grow a nursery and then go for a transplanting operation. So some of the innovations are available, proven, but they are still to become popular among the farmers, sugarcane growing farmers. Interculturing and weeding operation also needs a mechanization. We have power weeders available in the country now. We should use it. Spraying operation, when the crop is small, we can go for, but when the crop grows tall, I think we are attempting now drone spraying. And probably drone spraying would work if it is standardized properly after some time. Then detrashing, loading of the sugarcane in the truck, transport of the sugarcane, trash management in the fields, ratoon management in the field. These are the different operations where require lot of machinery for development. In India, we have a lot of machinery already developed. We have Indian Institute of Sugarcane Research. We have Central Institute of Agricultural Engineering at Bhopal, Tamil Nadu Agriculture University, and many other state agriculture universities who are located in sugarcane growing areas are developing lot of machines, location-specific machines for sugarcane cultivation. However, these machines are still an inventory in their book, and we have to facilitate these machines to come to a commercial stage and then make it available to the farmers. If I look at the inventory, I think hundreds of machines of different types are available. They are not available to farmer, they are available in the inventory book. I think we need to facilitate this inventory to be seen on the farmer's field. That's the gap. Animal-drawn sugarcane planters, long back, we are not talking about it now. Nobody uses animal now. Power-operated sugarcane shed cutting machine, tractor-drawn semi-automatic sugarcane planter, disc-type sugarcane cutter planter, tractor-mounted riser sugarcane planter. These machines are available for planting of the sugarcane instead of labor operation. They can substitute labor and they can be efficiently used. Then for ratoon management, device is developed by Indian Institute of Sugarcane Research, still not become very popular. There is sugarcane earthing up hoe, sugarcane stubble shaver. One is available in this exhibition also right now. Then harvester, I will talk about it. And then these institutions which I have mentioned, there are public institutions as well as there are some private industries who are already in the production of machinery for sugarcane cultivation. We have seen Shaktiman device outside harvester. They have some other sprayer also displayed. New Holland, John Deere, global companies who are selling their harvesters in the country. There is a Rohit industry in Pune who is also producing implements for sugarcane cultivation. So there are a lot of individuals attempt made as far as mechanization of sugarcane is concerned, but they have to still see the farmer's field, and that's where we need to concentrate upon. The mechanization stages, primary tillage, secondary tillage. Now we have a manual planting predominantly. We have to go for cutter planter. Interculturing operations, we have a lot of power weeders available. Now fertilization, we are just throwing fertilizers again. We have a fertilizer applicators mechanically. Spraying operation, pesticide, initially it's okay, but when crop grows, you have to go for a drone spraying. Chopper harvester, which is now becoming popular in Maharashtra. We still do not have a whole cane harvester successfully used in our country. And we'll have to make an attempt. Some industries are making an attempt to have a whole cane harvester. It is not yet available. Attempts are being made at Sangli, at Pune by some industries. They are not yet successful. They are still at prototype stage. But the chopper harvester made by Shaktiman probably is becoming very popular. Most of the sugar industries in Maharashtra are buying it, but the limitation is its initial cost. Cost is very high. Although it is subsidized, but still I think it is not affordable. But as far as efficiency is concerned, comparatively it is better. No harvester in India is still 100% efficient. So what we are using is just because labor is not available, we are harvesting with the machine. That's the state. Then there are several other sugarcane harvesting, sugarcane mechanization stages. I will talk about the ratoon management, which is very important. Our second and third ratoon also can yield as good as the first crop. And where if you go for scientific ratoon management, which is not really followed by the farmers. So we have ratoon management device which can go for shaving of the ratoon, stubble shaving, as well as fertilizer application in between the rows. Trash shedder, after harvesting, trash need not be burned. I think we are not burning now stage. We are incorporating this trash into the field. So these machines are available right now. Now I am not talking about the land preparation machinery. These are almost very common in India. Now the cutter planter, where sugarcane sets are placed, and then manually the sugarcane is placed into a box, and then when the tractor moves forward, it cuts the set and drops into the field and then complete the cover it and then to be irrigated. It's replacing the manual planting of the sugarcane. But these are not yet becoming very popular. I think sugar industries has to take initiative to adopt the mechanical planting by farmers. Now this is another method. You have to grow a sugarcane nursery. For this purpose, we have bud chippers available, motorized bud chippers, manual bud chippers. You can cut only the bud of the plant, and bud is planted in this kind of nursery. And when nursery plant becomes about 60 days old, this can be transplanted using a transplanter. Now, this transplanting method saves about 30% of the water. You can save 2 months of the field operation. After 2 months, you can go and start transplanting. So, a lot of saving in the water, a lot of saving in the energy in case of transplanting. This also has to be popularized. Although the transplanter are available in the country, in the market, they are still not in a very commercial production. They are not still in use by the farmers. So the next stage of mechanization after tillage is mechanical planting and mechanical transplanting. So transplanting is the one which probably is more optimum than directly going for a shed cutting planting, semi-automatic planting. I think hereafter, the future generation sugarcane cultivation should see the transplanting of the sugarcane growing through the nursery. Nextly, interculturing operations, we have a lot of power weeders. Tractor-operated, self-propelled weeders are available in the market. You can see some of the models in the exhibition also. But some of the power weeders have become very, very popular in last few years in the country. And they are selling in hot cake, and they can be used for sugarcane interculturing, making the furrows and also bunds in the sugarcane is almost mechanized now. Now harvesting has a lot of problems. Although we are going for chopper harvesting, if the sugarcane field is lodged, if you find lodging in the sugarcane field, this has a constraint. Secondly, if you have a moisture content in the field, the wet soil gets into the cutting blades, they block the blade, and the operation stops. So there are certain constraints in the field when we go for a chopper harvester. The second constraint is that the loss of weight after harvesting, because there are smaller 9-inch bits, they are carried to the sugarcane factory, transported to the factory. If the time is more than 24 hours, probably you have a loss of weight, around 3 to 5% loss of weight. And otherwise also, most of the factories, I do not see that the harvested cane directly goes for a crushing. They have to wait maybe 24 hours to 48 hours sometimes. And during that period, I think chopper harvester cut cane will find loss to the farmers because it will have a loss in weight. I think these are some of the constraints that we have to overcome. And whole cane cutter, we are still trying. I don't think we have still solution about whole cane cutter. But I feel that better than chopper cutter, we should go for a whole cane cutting harvester whenever these machines come to a market. China has tried that whole cane cutter, Brazil, and they are using it, whole cane cutters. We are not still using, we do not have an optimum machine for cutting still. In case of sugarcane harvester, there are a lot of issues. As mentioned by Dr. Ma also, that the base cutting in moist soil, proper cutting, then removal of the stalks, windrowing, then detrashing, these are the problems. And in case of harvester, at least I was told that there are about 200 harvesters in the field now in Maharashtra. And if those number is growing gradually, every year I think it's heavily subsidized by the government also. And sugar factories are probably relying more and more on sugarcane harvester now than because of the labor scarcity. But the critical in harvesting is that the operators who are operating the harvester, chopper harvester, they have to be fully skilled and fully trained for operation in the field. We do not have a systematic training to these operators. If there is any problem in the field, probably they'll have to depend on someone. That kind of service is not yet available in our country. Secondly, there are a lot of design and technical parameters, and because of those technical parameters, if operators do not understand properly what has gone wrong, probably the operation will stop. These harvesters are running almost 24 hours. Day and night, they are harvesting the cane. And during that harvesting, if there is any problem, I think the harvesting stops and the chain of those services like transport, collection and transport, etc., disturbs. That's why we still need to have clear-cut, better skill development of operators and good quality machines. I was told by Shaktiman engineer here that they have now better design, improved design. These kind of innovations will continuously be going on, and every year we'll find some better machine coming into the market. But I hope that in years to come, we'll have a better machine for chopper harvester coming in. And I also wish that we get a whole cane harvester in the market in couple of years or so. There are a lot of limitations in the present, I have already told, but in the new generation mechanization, this dependent on the mechanical gadgets probably will have to be reduced. We are going in the country, a lot of research is going on robotics and sensor-based, artificial intelligence-based technologies in mechanization also. I think next 3 or 4 years, we will see robots working in our field. Our scientists are working, our engineers are working, and I have seen a couple of days a review of the farm mechanization in India. Lot of machines, people are working on robotics in agriculture machinery. And in sugarcane also, we have not yet started, but I'm sure that next couple of years, we will have best of the robotic machines coming into the market, at least the prototype machines coming into the market, and we will be trying that, and that is the future of mechanization. In case of billet chopper, I think about 5 to 10% to weight loss of sugarcane is a net loss to the farmers. Probably, I think we have to consider from farmers' angle also the cane loss because of the chopper harvester is a loss to the farmers that is not compensated by any sugar mill. So I think that is also a constraint that is not known. We look at the ease of operation, but we also look at the farmers' loss. Ratoon management and trash cutting, I think these kind of machines where you go for interculturing operation, fertilizer application in the ratooning, then trash shredding, this will help. The next stage of mechanization, drone spraying, probably there is a demonstration in the field where drone spraying is demonstrated. But as I see now, a lot of people are using, some of the sugar mills in Maharashtra are using drones for spraying the sugarcane field. When the sugarcane grows, it is very difficult to spray the field. And that's where drones are appropriate device to spray those fields. However, the standardization, optimization of drone parameters for spraying the fields are not yet done. And I am requesting all the innovators and research engineers who are working on drone in the Mahatma Phule Krishi Vidyapit Rauri, that they should standardize and optimize all the parameters of drone for accurate and precision spraying by the drones. Now, the spraying is done haphazardly, it's not accurate. We are unnecessarily spraying a lot of chemicals. It is not, whether it is effective or not, also we don't know. We are haphazardly doing it, but while doing it, we must go for optimization, and optimizing different parameters of drone spraying is necessary in years to come. Then harvesting precision, Chinese people, they say they are trying now all the sensor, installation of sensor on the harvester, where the sensor will control the depth of the cutting, height of the cutting of sugarcane. They will ensure the precision in cutting. They will also ensure the transportation. They will also monitor the yield during harvesting. When the sugarcane is cut and being loaded, same time you can estimate what is the yield of that sugarcane, how much ton it is going to give. That also is possible. There are machines in abroad used where there is a continuous harvesting is going on simultaneously. The half an hour yield is displayed. Now this plot has given this tons of yield, something like that. So you sugarcane harvester, so it is possible that while harvesting continuously, you can monitor the yield of that sugarcane yield. You don't have to go for and wait for the sugar factory to give you weight. You can look at your machinery and say, this is the weight of my sugarcane. I'm going to get 25 tons in this harvest, something like that. So these are some of the mechanization issues. And to conclude, I say if we are steadily moving towards mechanization. We are not fully acquainted to mechanize sugarcane in all the operations, especially planting, spraying, interculturing, and harvesting. These are critical issues. Tillage, we are not talking. Land preparation is fully mechanized. Now, our public organization, research organizations, and some of the private industries are working on mechanization devices. They are at very right stage. They are progressing every year. And I believe that next couple of years or so, we'll have better designs of the machinery for sugarcane cultivation. And I would like to say that private sector is more active in mechanization than the public sector. Public sector has a lot of inventory. They are very slow in commercialization of those units. Maybe they have their own constraint, inbuilt constraint in their organization. But I believe that private sector is aggressive, and lot of machines, need-based machines by different industries are in making. And next few years, probably we'll see sugarcane is better mechanized crop in the country, and we will definitely substitute labor, go for cost effectiveness of sugarcane production, and also will become a globally competitive if we go ahead with the fully mechanized sugarcane cultivation. Thank you very much.
एक दोन क्वेश्चन घेऊ आपण. हां, कदम साहेब.
Hello, myself is Dr. J.R. Kadam, ex-Associate Director of Research, Zonal Agriculture Research in Solapur. I must congratulate to Dr. V.M. Mahinde sir, former Vice Chancellor, PDKV Akola, and Chairman IMIT Pune. He has given a very excellent lecture on status of sugarcane mechanization in. Most of the time I am listening his lecture, and he is having a very practical importance. We have conducted one seminar on cane harvester through DSTA Pune in 10th of June 2020. There is a several question from the farmers that cost of cane harvester is more than 1 crore. So that how we can reduce the cost of cane harvester? No doubt we are saving the labor. And another question is that government is giving 40 lakh subsidy to the cane harvester, and 60 lakh they want to pay. The total in a year, only 4 months we are operating this cane harvester, and 8 months it kept as a ideal. Therefore, farmers want to pay the interest of the bank or loan, so that how we can reduce the cost of cane harvester, and is there any substitute for us?
Thank you, Dr. Kadam. First question is about the cost effectiveness of the harvesting operation. I have calculated the cost of operation in mechanical chopper cutter harvesting. If we look at scientifically the cost calculations, the break-even point is every harvester should cut about minimum 15,000 tons of the sugarcane annually. Then it is a break-even point.
Okay.
The profit will come only after 15,000 tons of harvesting by every chopper cutter. And if you are harvesting on an average 20,000 tons per year with one chopper, then it becomes little economical. Otherwise, if you have a season like this year, scarcity season, no sugarcane chopper harvester can make a profit. They are in loss. They will not be able to repay the bank loan also,
Yes,
bank
yes.
interest also. That is the kind of economics. So we'll have to rework economics. I think sugar mills also has to work on economics. Your second question is about the subsidy. The initial cost is high, definitely higher. It is not affordable. But if there is a good competition in suppliers, I think they will compete with each other to minimize the cost. Now there are only two, chopper cutter is produced by only two companies, New Holland and Shaktiman.
Okay.
And cost reduction will come through competition. We do not know the cost of production of their industry, but we can't help that. But the subsidization by the government is going on, and farmers are able to buy only because of subsidy. 30,
Yes,
40, about 30, 35 lakh subsidy, I think good enough, but they are buying it now. But all farmers are not getting subsidy for buying sugarcane. So that is different issue. But definitely cost of operation has to be really economical. If cost is higher, probably this sugarcane harvesting boom, which is coming up now, after some time, I think those who are owning sugarcane harvester, they will say, "Ki, I'm just throwing it out because it's not profitable." So that's the right now, situation right now.
Okay, sir. Thank you.
Yeah, yeah.
One more question.
Arvind Chidasama, Sugar Industry International. Quite a few years, more than a few years ago, Australian researchers found that when you increased the inter-row spacing from 1.6 meters to 1.8 meters, cane yields were not impacted adversely. But what happened was that over 1,000 hectares, you could save 40,000 liters of fuel. And I was just wondering from your particular experience, is this kind of systems implemented in the cane harvest operations that you are familiar with? Thank you.
Thank you. I think we'll have to minimize the diesel consumption by the engines. And I was told yesterday that they have now a 6-category engine. I think they are improving the engine. When the engine, if we look for an engine efficiency in the harvester, probably cost will also go up. Initial cost will also go up. So there is a catch. You want better efficient machine at higher cost, or you want a machine with low cost, low efficiency. So these kind of proportions, I think in years to come, when they subsidize heavily, I think they will come down. Cost will come down after some time. But we definitely need more efficient engines and other power source. Like we were talking about yesterday, the minister was mentioning about the ethanol engines, ethanol-based engines, blended fuel engines, or the electrical vehicle engines, something like that. Alternatives will come in the future, but right now, I think status is that whatever technology we have, we are using it. Thank you.
Sir, I am from UP, and particularly from eastern part of UP. So I am giving a situation in eastern part of UP. The farmers having very small holdings, about 0.8 hectares, and the land size is about 0.2 hectares, and in scattered area. So is there any scope of mechanized harvesting in that particular area?
Yeah, that's the issue all across India. We have only small farms. And UP or Maharashtra, we have small farms only. This is an issue. Right now, what we have is the large machines that we are using it. But there are small machines, small harvesters also. But as I mentioned, they are designed, but at prototype stage, they are not seen a commercial angle. And they need to be bring out. If you go to the Indian Institute of Sugarcane Research at Lucknow, they will show you a small harvester where you have to do a lot of manual operation. Now you can cut the cane, you can detrash it, you can transport it. Small farmers, you should have a small set of machinery. That's available, but that's not seen a commercial end of it. So that's where I'm appealing all the public organizations who are doing research, they should commercialize and go to the farmers so that will be available for UP farmers. UP, I still doubt about Shaktiman type of chopper type of harvester used in UP. Okay.
Thank you, sir. Thanks.
Thank you. Now we are closing the session. Before that, I must thank all the speakers from my bottom of heart that they have presented very nicely, and presentations were really full of information, some videos, and they have taken the complete overview of the two important subjects. That is, one is micro irrigation. Two speakers spoke about micro irrigation, and two speakers spoke about the mechanization. I think I will not reiterate the same thing again, but I think all the demonstrations, like in particularly in the micro irrigation practices, have been demonstrated at Vasantdada Sugar Institute. I think many farmers have seen that. That is drip irrigation, then surface irrigation, sprinkler, even one more, that is a water gun, and one more innovation, that is inverted micro sprinklers. We have also conducted some trials at MPKV Rauri on the inverted micro sprinklers, so that microclimate can be developed in the sugarcane, and we got the results that almost 15% more yield if you put the inverted micro sprinklers. So I request all the farmers, मैं सभी फार्मर्स को फिर एक बार रिक्वेस्ट करता हूं कि वो फिर से एक बार देख लीजिए, उनके जो टेक्निकल पीपल है उनसे जानकारी ले लीजिए. And then Kulkarni Saab also given the complete overview of the upscaling of the drip irrigation. हर एक टेक्नोलॉजी की अपने कुछ एडवांटेजेस होते हैं, कुछ डिसएडवांटेजेस भी होते हैं. अगर ड्रिप लगाई तो जब मैकेनिकल हार्वेस्टिंग के तरफ हम जाएंगे तो उसको निकालना पड़ेगा. तो उसके लिए हम जब देखते हैं तो फिर वाटर गन एक अच्छी टेक्नोलॉजी है, लेकिन उसमें जो हार्वेस्टिंग के लिए वो सपोर्ट कर सकती है. तो देयर आर प्रोज एंड कॉन्स फॉर द एवरी टेक्नोलॉजी. सो कौन सी टेक्नोलॉजी आप यूज़ कर रहे हैं उसके ऊपर भी रहेगा. एंड ड्रिप के जो बेनिफिट्स तो है, आपको पता है कि आप काफ़ी लोगों को, किसानों को पता ही है, कुछ लोगों को पता नहीं है. उसमें फर्टिगेशन कर सकती है, देन केमिकेशन कर सकते हैं, कुछ वाटर मेजरमेंट आप कर सकते हैं, और उसमें यूनिफॉर्म वाटर भी जाता है. तो देर आर इश्यूज है. लेकिन ड्रिप इरिगेशन में और एक इशू आ जाता है माइक्रो इसमें, कि जो आपको हम देखते हैं कि मेंटेनेंस किसान नहीं कर पाता है. तो मुझे लगता है VSI and MPKV Rauri also, we have to think some of the certificate course we should start on the maintenance of drip and sprinkler and such kind of automation techniques. And Kulkarni Saab has given very one debate making statement that whether does drip irrigation saves water. That is one आप डिबेट कर दीजिए उसमें. और एक्चुअली उन्होंने ये भी बात कही कि शुगर केन प्रोडक्टिविटी पर यूनिट लीटर वाटर यूज्ड, उसके ऊपर अभी वो जाना चाहिए, ना कि सेविंग इन द वाटर. सो ये जो है, फिर जो मैकेनाइजेशन अगर हम इसमें गए तो चाइना से आए हमारे एक्सपर्ट्स ने उनको बताया आपको. चाइना में भी देखिए तो उनके पास भी मैकेनाइजेशन शुगर केन में ज़्यादा हुआ नहीं है. Only just I was talking to him, only 5% sugar cane is being harvested by the mechanical harvesters. So उनके भी कुछ अपने प्रॉब्लम्स हैं, क्योंकि सीज़न एक प्रॉब्लम है. लेकिन वो जब बताया उनके पास 2 सीज़न है, तो उनका जो हार्वेस्टिंग पीरियड नवंबर से लेकर मई तक जाता है, बिकॉज चाइना एरिया इज़ वेरी बिग. तो आई थिंक ऑप्टिमम यूज़ ऑफ मशीन कैन बी पॉसिबल इन चाइना. इंडिया में भी अभी एक रिसर्चेबल इशू आ गया है मेरे सामने. अगर देखते हैं तो जैसे कैसे हम हार्वेस्टिंग सीज़न बढ़ाए, कैसे वैरायटीज़ हम डेवलप करें कि जो थोड़ा सा हटके भी चले. जैसे आपने जो 3 है, पूर्व हंगामी है, शुरू है, अड़साली है, उसके बाद भी और कुछ कर सकते हैं क्या, ये देख के अपने को सीज़न बढ़ाना पड़ेगा, ताकि शुगर केन इंडस्ट्री भी सर्वाइव हो. क्योंकि 3 महीने 2.5 महीने में शुगर इंडस्ट्री सर्वाइव नहीं हो पाएगी. तो ये एग्रोनॉमिस्ट के ब्रीडर के सामने ये भी एक रिसर्चेबल इशू मुझे लगता है कि आया है. उनसे बात कर रहा था कि उनके यहाँ भी जो लॉसेस है हार्वेस्टिंग में, चाइना में ऑलमोस्ट मैनुअल हार्वेस्टिंग होल केन जैसे हम ट्रेडिशनल वे से करते हैं और हार्वेस्टर के माध्यम से हम करते हैं तो उनका भी लॉस कम से कम 10% 11% तक आता है। तो क्या होता है कि हार्वेस्ट जब फैक्ट्री फिर उसको डिडक्शन देगी किसान को, कितना देता है मुझे पता नहीं, मैं वो कंट्रोवर्सी में नहीं जाऊंगा, लेकिन जब डिडक्शन जाता है तो किसान भी वो जो हार्वेस्टर की तरफ नहीं जाता है, क्योंकि उसको 2-3 टन का भी अगर 3 टन का भी अगर लॉसेस 4-5 टन का लॉसेस हो जाएगा पर हेक्टर में तो वो थोड़ा सा उसके पीछे नहीं जाएगा। तो दीज आर दी माहिंदे साहब ने पूरी मशीनरी लिस्ट आपके सामने रखी है। काफ़ी मैकेनाइजेशन ये 4-5 साल में इंडिया में नॉट ओनली इन शुगर केन बट अदर एरियाज में भी आ रहा है। तो मैकेनाइजेशन के सिवा आगे पर्याय नहीं है। लोग मिल नहीं रहे हैं, किसान खेती मतलब जो न्यू जनरेशन है वो खेती में नहीं आ रही है। लेबरर्स जहाँ पे ड्रजरी ज़्यादा इन्वॉल्व है वहाँ पे काम करने के लिए लोग मिल नहीं रहे हैं। तो एक बात तो पक्की है कि मैकेनाइजेशन के सिवा अपने पास दूसरा पर्याय नहीं है। और तीसरी बात जो एक्चुअली कॉस्ट ऑफ मशीन की बात की है, तो हम जैसे भी चर्चा करते हैं लेकिन वो मैन्युफैक्चरर ने डिसाइड करना चाहिए कि उनके मशीन्स लोगों तक जाए और एक नेशनल इंटरेस्ट की तरफ देख के आपको मशीन की कॉस्ट को भी थोड़ा सा कंट्रोल करना ज़रूरी होगा। क्योंकि 1 करोड़ अगर हार्वेस्टर की कॉस्ट है और उसके साथ 2 ट्रैक्टर और लगेंगे तो 1 करोड़ 40 लाख रुपीज़ एक हार्वेस्टर के ऊपर जाता है। तो इन्वेस्टमेंट भी ज़्यादा है और सब्सिडी कम है, और सब्सिडी कितने दिन तक आपको मिलेगी, कब तक मिलेगी, ये एक्चुअली इट इज़ नॉट श्योर। तो इसके लिए आप मशीनरी मैन्युफैक्चरर्स ने भी इस एक एक्चुअली नेशनल इंटरेस्ट की तरफ देखने के बाद मुझे लगता है कि उसके ऊपर आपको कॉस्ट कंट्रोल करना ज़रूरी है। और देश का जो कॉटन का हार्वेस्टिंग है, आप कॉटन नहीं अपना शुगर केन का हार्वेस्टिंग, वो आपको देखना पड़ेगा। तो मैं ज़्यादा समय नहीं लूँगा। पुनश्च एक बार मैं ऑर्गेनाइजर्स को बहुत बहुत धन्यवाद देता हूँ, उन्होंने मुझे यहाँ बुलाया और इस इम्पोर्टेंट सेशन को चेयर करने का मौका दिया। मैं मेरे तरफ से उनको बहुत बहुत धन्यवाद। थैंक यू वेरी मच।
Thank you, Chairman, sir, for the concluding remarks. Now I will request Honorable Chairman to offer the mementos to the distinguished speakers. First one is Dr. Render Felix. He will receive the memento at the hands of Chairman. Dr. Kulkarni Saab, he will also receive the memento at the. Now Sachin Ma, he will receive the memento. And last speaker, Dr. Mahinde sir, he will receive the memento. Now I will offer the memento to Chairman sir. Thanks to all the speakers and Chairman sir for this session. Now there will be break for the lunch. Next session will start at this place at 2:30 p.m.
Hello. I request all the delegates to gather in a conference room. We start our session soon. सर्वांनी कॉन्फरन्स हॉलमध्ये जमायचं आहे. सेशन लवकरच स्टार्ट होईल. uh, distinguished guests, esteemed colleagues, and honorable delegates. Good afternoon to each and every one of you. It's an immense pleasure and profound honor that I extend a warm welcome to all of you to this coordinating session on sustainable sugar beet industry emerging challenges on our prestigious third international conference and exhibition 2024 on sustainability challenges and opportunities in global sugar industries. This session will be chaired by Honorable Dr. Solomon Sir. So I request him to chair the session and come on the dais. So in this session, there is a four speaker. So one of our Mr. Jean-Noël Evrard, which is a global head, CES Vendra Belgium. I request him to come on the dais. So another is Dr. Ashutosh Kumar Mal. He is a principal scientist, Indian Institute of Sugarcane Research, Lucknow, and he specially works on sugar beet. Mr. Timothy Mason, which is Executive Secretary, World Association of Beet and Cane Grower, France. And our fourth speaker is Mr. Richard Sauvage, which is a responsible commercial, Maguen, France. I also request to come on dais Mr. Fabien Mazet. It is my distinct pleasure to introduce the esteemed individuals who will be leading and sharing their invaluable insights in this session of our third international conference and exhibition on sustainability challenges and opportunities in global sugar industries. Firstly, I introduce our session chairman, Dr. Solomon Sir. He is an agriculture scientist with great repute. He has devoted his whole life in research and production of sugar in India in a very serious way. He obtained his PhD degree in biochemistry in 1978 from Punjab Agriculture University, Ludhiana, and also did post-graduation diploma from Datamatic School of Management, Mumbai. He worked as a scientist in various capacities. His association with Indian Institute of Sugarcane Research, Lucknow, as a director is a think of Recon. Under his vibrant leadership, the institute took several initiatives and made policies for improvement of sugarcane research and sugar production in India. He was also appointed as 38th Vice Chancellor of Chandrasekhar Azad, University of Agriculture, Science and Technology, Kanpur, Uttar Pradesh. He also contributed more than 37 years in scientific research guidance, teaching in sugarcane and sugar industry, and published more than 150 research papers on sugarcane, sugar industry in various national and international journals. He has a vast national and international experience in his particular field and visited many countries for his research and professional work. Currently, he served as the president of Society for Sugar Research and Promotion, editor-in-chief of SugarTech Journal, executive editor of IPSIT and SugarTech newsletter. So after this brief introduction, I pass on this session to our chairman for further proceeding.
A very good afternoon to all who are on the dais and in the hall. I also welcome my session team, Dr. Shitoleji and Dr. Sarvase. And it's an honor to welcome the esteemed speaker. We have four distinguished speakers in this session. First is Mr. Jean-Noël Evrard. He is head of customer service, SCS vendor of Belgium. He will be speaking on a complement to sugarcane. for sugar and ethanol production in tropical and subtropical areas. Our next speaker is Dr. Ashutosh Kumar Mal. He is principal scientist from Indian Institute of Sugarcane Research, Lucknow, India. And he will be talking about the sugar beet breeding in India, retrospect, challenges, and prospects. Our next speaker is Mr. Timothy Mason. He is the Executive Secretary, World Association of Beet and Cane Growers. He is an agronomist from Institut National Agronomique, Paris, France. He will be sharing about his experience on carbon farming, why and how improving the carbon footprint of sugarcane and sugar beet. And our last lecture will be shared by two distinguished speakers. One is Mr. Richard Suavage. He is sales manager, responsible commercial, Maguin, France. He will talk about the advantage of the beet sugar factory compared to the cane sugar factory, which is very interesting and important aspect for Indian sugar industry. So I welcome you all and hope we have a very nice and session today on this very important crop. I would request Dr. Chitole to kindly introduce our first speaker, Mr. Jean-Noel Everard.
Our first speaker is Mr. Jean-Noel Everard. I will shortly introduce to him. Mr. Everard developed a profound understanding and appreciation for sugar beet industry from an early age. He completed his degree in agriculture engineering from esteemed ISA Institute of Superior Agriculture in Lille, France. He immensely contributed for development of sugar beet varieties suitable for specifically subtropical conditions with a specific focus on India. Mr. Everard initiated several experiments in collaboration with renowned institutes and universities in India, and presently he is working as a global head at CES Vendera of Belgium. He is an valued leader with our organization. He is a highly accomplished professional with extensive expertise in sugar beet seed industry. So I request him to deliver his talk on sugar beet, deliver his talk on sugar beet, a complement to sugarcane for sugar and ethanol production in tropical and subtropical areas.
To move the slide from. Yes, okay, okay, fine. Okay, yeah, that is the point. That's okay. Thank you. Thank you, Chairman. Thank you, everyone, to be there. I'm very proud to be here for this conference, international conference in VSI. My speech today will be about sugar beet. Sugar beet should be a special crop we are using in Europe, but also in India already, in some countries, in some states. The idea is not to change the sugarcane by sugar beet, but to have sugar beet as complementary crop for you. You have to think about today, the way to maximize the present is to anticipate the future. This morning, we have a big speech about how to limit the usage of water. Sugar beet could help you. We already yesterday have a speech from the ministry about bioethanol, bioproduct. Sugar beet can help you. I will say sugar beet will help you on that domain because with this kind of crop, you have plenty of solutions to help you to grow sugar, ethanol, and other bioproducts. I will show you a short animation here about what we can do with sugar beet. This figure is for mainly in Europe, but also can be used in other countries. On the top of this 4 products, you can have plenty of other production, like pectin and other. So Cess Van der Haaf, behind this name, it's already a huge company. We are selling sugar beet seed in many countries. You can see here, many countries for Cess Van der Haaf, we are selling some sugar beet seed from US to Japan, from China as well, in India already, in north of India, in Chile as well, but as you can see, also in Morocco and Egypt. That means the sugar beet is not a problematic with the hot temperature. In this country, the temperature could rise more than 30, 40 degrees, which is not a problem for sugar beet. Just a few words about what it is behind the name of Cess Van der Haaf. Cess Van der Haaf is a global player in sugar beet sector. We specialize in every aspect of the sugar beet, seed production, from the breeding, and since 2005, Cess Van der Haaf has been part of the group Florimond-Desprez, which is a huge group in seed business. So Cess Van der Haaf is working at the world level. That is the main building of Cess Van der Haaf in Belgium, in Tienen. You can see 3 buildings here. The main building is the head of Cess Van der Haaf. We have the factory. Factory for us means all to prepare the seed, to treat the seed, to polish the seed, to have a good seed at the end. And then on the left side from your screen, we call it the ZVIC, which is a greenhouse where we are breeding the seed, the sugar beet, a new technology. More than 1 million of new crossing every year in that building to improve the quality of the sugar beet seed. Our history in sugar beet business is very old now. More than 140 years ago, we start in breeding of the sugar beet seed. On top of that, more than 600 people are working in the company in Cess Van der Haaf globally, with 32% of our worldwide staff is on R&D, research and development. And we reinvest every year more than 15% of our turnover in R&D, research and development. What about India and Cess Van der Haaf? Our history with India started already many years ago. You will see in few seconds. Cess Van der Haaf in India, we start already in 2005 with the first trial we did in India. It was not in VSI, it was in Karnataka state, but later on we came in VSI to test our variety, to adapt the best genetic we can to have a climatic condition like in India. So we did some partnership with PCI, Pest and Control of India, and we did extensive trial with VSI here. We did also some trial with industry. We teach some farmer or some student time to time, and we also provide some seed for sugar industry and sugar beet also in Punjab. In this country, in this state, a lot of sugar beet are already in the ground. Let's see, that is a picture took already a few years ago in Karnataka, where it's still possible to grow sugar beet. This beet is quite a very nice beet for us, the same as we can see in European country. Let's see the second picture of sugar beet field in Punjab. You can see with the tropical conditions, sugar beet can grow easily. In terms of how to grow sugar beet, you can mix you can mix your sugar beet between 2 rows of sugar cane. That is still possible. You should not forget such element. The key success growing sugar beet in India need to respect some element. First is the crop rotation. The crop rotation, as you know, need to be respected also for sugar beet. That means the sugar beet should not come back on the same field after 3 to 4 years. And this will help you to reduce the insect, the disease, but also to have a better soil preservation. And at the end, that will increase not only the sugar beet yield, but also other crops in your field. For India, this rotation could be sugar beet 1 year, and then other crops like maize, winter wheat, or pulse. That should be adapted by you. I mean, that is a kind of element. Again, the key success for sugar beet, to produce sugar beet, is the soil preparation, like many crops here. I mean, the seed bed preparation is the key. This morning we talk about mechanization. For sugar beet also possible to have a seed bed preparation for sugar beet. It's very small seed at the beginning, but if you have a good seed preparation, your crop will grow faster. In India, this kind schema could be helpful for you to have a furrow and ridge, to have such element to grow sugar beet. Thank you. At the end, you need to have a good objective. Your objective should be to reach 36 to 40,000 plants beet per acre. For this, with this population, you can expect to have a good yield. If you are lower than that one, it would be a difficult situation. Again, here in this field, you see you are reaching more or less 40,000 plants per acres. That has been done in India, in Punjab, the same the next one. That is also possible to reach such good yield at the end. The yield in this case is more or less 40 tons per acre, which is a good, very good one. In average, we should not estimate at the beginning to reach between 20 to 25 tons of beet per acres. Again, like other crop, key success for sugar beet crop is to respect some rule in terms of fertilization. The first, need to have a soil analysis. That's very key for farmer, you know that already. So the optimal fertilization per acre should be for nitrogen, more or less 48 kilograms of nitrogen, 50% at the sowing time, or 50% at the 4 to 8 leaf stage of the beet. And then 24 kilograms of phosphoric, and then potassium, 24 kilograms. Also, the key success for sugar beet is the weed control. I have to say, weed control is the key for sugar beet, because if you don't control the weed, that will be a difficult situation. So you have many aspects, weed control, before planting with some chemical, at the pre-emergence, post-emergence, and also at the end, if necessary, need to use a manual weeding. I will show you a list of weed control herbicide possible for sugar beet. This will be too small to see it, but the list is quite long. I'm not so sure everything will be in India, but just to tell you that it still exists a lot of herbicide in Europe today on sugar beet. More and more are stopping to produce, but some are still using in India as well. Again, to maintain a good crop, you need to have a pest control, a good pest control. The Spodoptera litura is the most common here in India. We, as a salesman, already try to limit that with genetic, but we don't find any solution. There only should be a chemical solution for Spodoptera. Aphid, that is the same for bug. Lash miner should be okay. Other problem, that will be the disease. The sclerotium rolfsi will be very important also in sugar beet, depending on the climatic condition. On that topic, we have already found, with the help of VSI, some tolerance, genetic tolerance on that disease. Again, it's just a tolerance, it's not a resistance. Of course, you will find some beet with some disease, but not at disease should be with normal varieties. Other disease will occur, it should be Cercospora, leaf disease, and polluted mildew, and other one. Just some picture to illustrate what it is, Spodoptera, but I'm sure you know already that one. Sclerotium, you know already this one. And we have also polluted mildew. It's not the similar, but the same foliar disease. So, one of the last stage of sugar beet is the harvesting, how to harvest sugar beet. You can mechanize the harvesting of sugar beet. That is done already in Punjab. But if you treat well the variety, the crop during the process, the crop, the duration, the sugar beet do not have a ripening stage. That means if you keep it in the soil, the sugar beet is still growing, and the sugar content will increase. For you, as an industrial, you should have a good opportunity to manage your planning of the factory. But what is very important, you need to store the beet when it's harvesting no more than 24 to 48 hours. If you do so, that if you store the beet longer, you could have some trouble in terms of quality of your beet. Of course, as this is root, you need to clean as much as possible to avoid to have too much adhering soil at the end. Just to summary a little bit what it is the advantage of sugar beet. You could have a good yield, lower cost, only 6 months duration crop, less water needed, of course. You can imagine to have 2 crops per year in one field. That could be additional added value for the farmer. You increase the land productivity, and you have multiple co-products with sugar beet, ethanol, bioproduct, and also pulp for the day. At the end, yeah, I didn't speak so far about in saline soil. Sugar beet is quite good under saline soil. It's not optimal, but it's quite good one. So that is my conclusion on my speech about growing sugar beet in India is possible, for sure. I know some are already done. You will find many advantages for the farmer, also for the industry. Many products from sugar beet, sugar first, if you need it, but not only, ethanol, alcohol. We can imagine 1 ton of beet can produce more or less 100 liters of ethanol. The pulp for cattle feed, which is very good product, cattle feed like it. Lime for the fertilizer, also for the soil, to get a better soil at the end. And on top of that, you know that it's a short crop duration, 6 months maximum. So you can imagine to drill the beet in October, to harvest it in March, April. And at the end, able to grow on saline soil, I told you already, needs less water. But of course, you will find some obstacle, like disease, but that could be overcome. Don't rush, work hard, and look for support. Many people in India know already how to grow sugar beet, so it should be possible. Thank you.
Thank you, Mr. Everard, for your informative lecture on sugar beet. I would like to invite our next speaker, Dr. Ashutosh Kumar Mal.
So our next speaker is Dr. Ashutosh Kumar Mal. He did his PhD in genetics and plant breeding, and he secured a postdoc at Erie, Philippines. He's not only worked on sugar beet, he also developed 15 rice varieties from different ecologies and 13 varieties in different forage crop. Dr. Mal significantly contributed in sugarcane improvement program and worked for a seed replacement. He also received many prestigious awards from different international, national, professional societies and published more than 96 research articles in international and national journals of repute and written 3 books and 27 book chapters. Presently, he is working as a principal scientist and sugar beet breeder at Indian Institute of Sugarcane Research, Lucknow. So I would like to request Dr. Mal to deliver his talk on sugar beet breeding in India, retrospect, challenges and prospects.
Good afternoon to all. First of all, please accept my greetings from ISR Lucknow. And I like to give thanks to VSI management who gave me such opportunity to be here. I'm going to present the sugar beet breeding in India, retrospect, challenges and prospects. Sir, in 18th century, sugar beet has been introduced in most of the world like Russia, Ukraine, North America, while in India it is introduced in 1950s. Regarding research and development of sugar beet in India, it is introduced in 1950s, and during 1960s, ISR initiated organized research work on sugar beet. During 1971, ICR launched AICRP, All India Coordinated Research Project on sugar beet. And during 80s, after carried out the intensive research on sugar beet, on various aspects of sugar beet and seed production by the ISR, and ISR developed so many varieties like LS6, ISR Comp 1 and LKS1. Sir, during 2004 and 8, ICR started network project at several places led by IISR. After then, ISR was engaged in germplasm conservation, maintenance, and utilization. Now, these days, we are focusing on to develop indigenous varieties for maximum ethanol recovery and for indigenous material for water stress condition. Regarding the characteristics of sugar beet against the sugar cane, sir, you see, sugar beet has several advantage over sugar cane. The crop needs half the time in the field compared to sugar cane, which needs whole the year. It requires lesser water for cultivation, leading to water saving, higher sugar recovery, and ethanol potential than sugar cane. Sugar beet is highly tolerant to salinity and alkalinity. It appears to be most suitable crop to cultivate several thousand hectares of uncultivable land, Usar land, in India. This crop may be useful in reclaiming such soil. And for the sugar beet, no need separate lands for the cultivation of sugar beet. It can be grown as an intercrop with autumn planting sugarcane. Sir, regarding research and development ISR, sir, ISR has been actively involved in sugar beet research and development for several decades, as mentioned in previous slide. The institute placed emphasis on genetic resources, varietal development, seed production, and the widespread promotion of this crop. To achieve this objective, AICRP, All India Coordinated Research Projects, and contractual research projects have been strategically implemented in the past. Sir, regarding breeding activity at Muktesar, sir, ISR have one center at Muktesar for sugar beet, where we engage in seed production, germplasm maintenance, and storage packaging of the seed. These activities encompass both indigenous and imported material. For the seed production, the essential requirement for seed production in India is vernalization, a process facilitated by the exposure to cold temperature. In India, this condition is met at high altitude exceeding 5,000 sea level. 5 specific regions in the country have been identified by IISR, a prime location for sugar beet seed production, like Mukteswar and Ranichori Kumayu Hill in Uttarakhand, Oli, Garhwal Hill in Uttarakhand, Simla and Kalpa at Himachal Pradesh, and Darjeeling in West Bengal. Sir, sugar beet seed production implies 2 distinct methods: direct seeding and transplanting. The transplanting method is primarily utilizing for the cultivation of breeding stock and elite seed varieties. This approach involves growing the sugar beet plants at Lucknow for 1 month till first fortnight of December and transplanting it to high altitude in second fortnight of December to curtail the time duration for the seed production. This method is particularly advantageous for the maintaining the genetic purity and quality of the seed. Sir, this is the flow chart of both the methods of the seed production of sugar beet in India. As you can see, direct seeded methods needs at least 15 months for harvesting, while transplanting method needs 10 months for harvesting. In the transplanting method, sir, specific conditions are crucial for optimal development of stagling. Before uprooting, it is essential to trim the leaf of staglings. The ideal size of stagling root is within range of 6 to 14 centimeter and petiole size 4 to 5 centimeter. This careful selection ensured that only healthy and robust stagling are chosen for transplanting. Sir, for the successful growth of stagling requires a specific temperature range of 2 to 7.5 degrees centigrade for duration of 2 to 3 months. These temperature conditions are typically available at higher altitude in India, which I have shown in earlier slides, sir. Sir, for the transplanting, before the transplanting stagling at Muktesar, a crucial step involves trimming them to ensure optimum growth and development. Additionally, a preventive measure, the application of fungicide, is employed on the stagling that are prepared for transplanting. This fungicide helps protect the plants from potential fungal infections. Moreover, another essential practice involves thoroughly compressing the soil around the stagling once they are planted. This ensures the soil is tightly packed, providing stability to young plants and promoting better root establishment. Sir, the sugar beet breeding outpost in Muktesar is currently overseeing the maintenance and evaluation of 169 sugar beet germplasm. Additionally, the outpost is actively involved in the production of seeds of varieties LS6 and ISR compound in bulk. The seeds are cultivated to meet a specific demand and are supplied to growers across the country. Sir, every alternate year, we are freshening the seeds for maintaining their viability. So sugar beet seed can be categorized into two types based on the number of plants that can potentially emerge from single seed, monogerm and multigerm. Monogerm seeds are designated to produce single sugar beet plant per seed. Through the advancement in breeding and seed technology, monogerm seeds have become increasingly popular in European countries. And multigerm seeds, on the other hand, have potential to give rise to multiple plants from a single seed. So the maintenance and preservation of sugar beet seed are crucial aspects of ensuring the availability of high quality seed for cultivation. Sir, sugar beet seeds require optimal storage condition to maintain their viability. A specialized seed storage facility equipped with controlled temperature and humidity levels are essential. These conditions help prevent premature aging or deterioration of the seed, ensuring longer shelf life. Sir, these are the glimpse of the cold chamber. This cold chamber ISR maintaining at Lucknow, sir. Sir, at Lucknow, we are working on 5 essential areas of sugar beet. These are development of indigenous genetic stock for high sucrose and root yield, development of indigenous genetic stock for high ethanol recovery, identifying and evaluating germplants for abiotic and biotic stress, and identify germplants for less deterioration after harvest. So the genetic requirement of sugar beet play a crucial role in determining the crop's adaptability, productivity, and resistance to various environmental stresses. We have been focusing on higher root yield with high sucrose content, with low impurities, high ethanol recovery, moderately resistant to disease, insect pest, and abiotic stresses. The primary economic value of sugar beet lies in its sugar content. Ideal genetic traits involve higher sugar concentration in the tap root. Sugar beet are cultivated for their ability to accumulate and store sucrose, making them a valuable sucrose for sugar production. Sir, commercially, ISR developed two varieties like LS6 and ISR Comp1. LS6 is high yielding variety with moderate sugar content, has been identified for cultivation in tropical and subtropical region of India. This open pollinated variety has been developed through process of mass selection. It is multi-germ and hardy variety. ISR Comp1 is developed through open pollination. It is a multi-germ and self-fertile variety exhibiting robust germination in both normal and cold climate. Sir, we have identified 10 to 12 indigenous varieties for certain characteristics. And very recently, we have sent 4 germplasms for certification to ICR for different characteristics. These are LKC 2000, 2020, 2010, and 2007 for different characteristics. Sir, apart from varietal development, ISR has made significant strides in the field of sugar beet cultivation by developing specialized machinery. This innovative equipment is tailored to optimize the cultivation process, enhancing efficiency and productivity in sugar beet farming. These are the glimpses of sugar beet field preparation and planting at ISR Lucknow. Regarding disease of sugar beet in India, sir, Alternaria, Cercospora, Rhizoctonia, Sclerotium root rot, Fusarium, viral disease complex are the major diseases. And we identified Hilma LS6, ISR Comp1, LK4, and SV887 as showed resistant response to major foliar diseases. We have identified 2 new species of Alternaria in sugar beet. Sir, Alternaria leaf spot is absent until February, but its incidence increases rapidly during March to April. Regarding insect pest of sugar beet in India, sir, the predominant pest, Spodoptera lutera, typically initiate its incidence in December, sir. The highest incidence rate of Spodoptera occurs during April to May, and optimum yield have been achieved with 15 to 30% defoliation, while yield decreased significantly with defoliation exceeding 90%. Sir, LKC 2020-1, L33, and LKC 2000 are resistant to Spodoptera lutera. Sir, we also identified two new strains of Spodoptera at Lucknow. Regarding minor insect pests, sir, there is a minor occurrence of aphid, leaf miner, spider, beetles, and mites in sugar beet crop. Ladybird beetle made their appearance approximately 30 days after sowing. Regarding weed in sugar beet, sir, we found 6 different weed species in sugar beet at Lucknow, sir, and 3 out of 6, sir, 3 major diseases: Chenopodium, Argimono, and Cyperus rotundus. These are the 3 major weed in sugar beet field. Apart from, sir, that, so ISR made collaboration with several institutes, public and private sector. Sir, I already told that we made a collaboration with the several sectors, and we have sent the seed to indigenous material to several centers. And after getting the information, here I am presenting the performance of indigenous material. At NSI Kanpur, sir, LKC 2020 and LKC 2010 maintained its superiority against the Czechs for ethanol recovery. Under the salinity condition, sir, several indigenous genotypes performing well against the Czech, while LKC 2000 outperformed for all the root parameters. Sir, fortunately, we made collaboration with this premier institute, Vasantdada Sugar Institute, Pune. Last year, we have sent the sugar beet seed here also. And you see LKC 2020, L33, LKC 11, and LK4 maintained superiority for single root weight against the Czech, while LKC 2006 and LKC HB showed superiority for the juice quality, sir. Sir, at Basantpur, Agriculture Research Station Basantpur, this is the typical semi-arid area in Telangana, sir. Here you can see the Czech variety ISR Comp 1 and LS6 maintained its superiority for yield and sucrose content, sir. Sir, we have also tested LS6 germ variety for Odisha region under drought stress condition. The results showed that the sugar beet yield was not much hampered after 7 days of drought stress, but with the increased drought stress, sugar beet yield was lowered. But still, the performance of LS6 is beyond expectation, sir. Sir, regarding the prospects, there is need of identification of saline and alkaline tolerant sugar beet varieties, increasing the alternative use of sugar beets such as jaggery and jam, utilization of byproducts of sugar beet, sponsoring sugar beet for cattle feed, development of technology for better ethanol recovery, so it is standardized machinery development, integrated cultivation and practices development like production technology and protection technology, and economic and financial feasibility as well as surety is very essential to promote this crop. For the challenges, India faces 5 significant challenges in sugar beet agriculture. The first hurdle lies in the necessity for extraneous fuel during the processing of sugar beet in mills. Additionally, the extraction of sugar beet juice involves the diffusion process, requiring the incorporation of supplementary machinery in sugar mills in efficient processing. There is a need for precise adjustment of crop protection and production technologies, particularly in target areas. The rapid deterioration of sugar beet poses a considerable challenges leading to significant post-harvest losses. So in that respect, we have to develop the crucial requirement for swift transportation. And last, there is a growing demand for increasing government involvement to formulate policies and incentives that support the development of sugar beet industry. Here, the glimpse of several visitors visited our sugar beet trials. Here, some of our publication in impact journals you can refer for further reading. Thank you, sir, for your patience.
Anybody have doubt, please ask.
Thank you,
To the
Dr.
respected
Mal.
speaker.
We can have, we will take questions after the all speakers are through. Then we can have few questions from the audience. So I would like to invite our next speaker, Mr. Timothy Mason, the Executive Secretary of World Association of Beet and Grain Growers.
So our next speaker is Mr. Timothy Mason, Uh, he's basically a plant breeder and work as agronomist for Cartelis Internationalis Cambodia. He also gives his expertise to the French Meat Industry Sector Union and Secretary of French Egg and Egg Products Union France as an economist. He also worked as an economist in French Beet Grower Confederation and presently work as an executive secretary for World Association of Beet and Cane Grower, France. And he is going to present his talk on carbon farming, why and how improving the carbon footprint of sugarcane and sugar beet. So I would like to request Mr. Timothy Mason to deliver his talk.
Hello, thank you very much. Thank you very much, and I'm very happy to be here. So my name is Timothée Masson. I don't work for a company, in fact, I work for an association. My association is called the World Association of Beet and Cane Growers. It is an association that group together farmers, independent farmers, so growers, who can grow sugar beet or sugar cane in different countries. We have 36 countries participating in our work. My president comes from USA, and the vice presidents are from Brazil, Morocco, and France. As we do not have an Indian Federation of Independent Growers, our member in India is a technical center, and I thank you very much for their invitation. The goal of my association is to bring people discuss together. If you are a sugarcane grower or a sugar beet grower, very often you have the same problems around the world. So my main work is to benchmark. For that, we organize meetings twice a year, one in November in London, and every spring or summer in a host country. So the last one was in Cali, Colombia for sugar canes, and the next one will be in USA for sugar beet. We make some publication. And we make some studies, mainly on economic studies, but this year my members wanted me to focus on carbon farming. So it won't be a presentation only regarding sugar beets, but it's also regarding sugar cane. Can we reduce carbon emission at farm level? How is it done around the world? And can it bring some money for the farmer? Because once again, I am paid by farmers. So the main topic is, for my study, can we imagine that one day we will be paid for carbon reduction or even carbon sequestration at farm level, sugarcane or in sugar beet? I will speak about carbon farming, which is a new term. 10 years ago, we did not speak about carbon farming. So what is carbon farming? Carbon farming, it's a way that we can reduce the carbon footprint in the farm by reducing carbon emissions or by trying to implement measures to store carbon in the soil. The goal of my study is not to compare sugarcane and sugar beet. It is not to compare sugar or ethanol. It is just to see how this topic is felt by the growers around the world. And for that, 21 members replied from India to Malawi or Mexico, from Sweden to Australia. And first of all, I'm not a technician, but just the technical part. How can we reduce carbon emissions? First, before to reduce, we need to know when we farm at farm level, where does carbon emissions come from? And in many countries that have a big interest in that, the first job that we have to make is to try to know at your farm, at your very specific farm, because we cannot make means. Average would have no sense for that. We need to evaluate the carbon footprint of your farm. And in many developed or such called developed countries, subsidies, you mentioned this morning subsidies are often paid in that purpose, to finance carbon footprints in a farm level. It's the case, for instance, in Europe, where you can get subsidies to have information about your carbon emissions. And if you try to analyze those results, the main emissions for cane and beet are first fertilization, and by far we will see it. Fertilizers emissions when you produce the fertilizers, but also when you lose in the field via N2O. We'll speak about carbon, but in fact it's not only carbon, it's green gas emission. On carbon, the most usual carbon, CO2, have an impact in terms of climate, but much less than CH4, which have 25 times more impact than CO2, and even more with N2O, nitrous oxide, 300 times more than CO2. And this is the main greenhouse gas emission in our crops, sugarcane or sugar beet. It is during fertilization. But also via fuel, and it can also be, of course, burning. I know in India, some harvests are still done after burning, and of course, this can release greenhouse gas emission. I've seen brilliant posters on the topic in the room next to here, but also energy for irrigation, land use changes, and so on. Let me try to present the big figures. For this, I tried an example. This example will be taken in France, my home country, with sugar beet, but it is exactly the same if you consider sugarcane. If I take an average standard farm, northern France, in a normal farm in France, it's 150 hectares, with sugar beet being grown on less than 40 hectares. In this farm, if you make a carbon footprint, you will find that 80% of the carbon emissions come from the fertilization. So it's mainly fertilization, with the 2/3 coming to losses in the field. So if you want to improve your carbon emission at farm level, which would be of interest for the civil society, you need to focus on fertilization. You have also fuel, but fuel is only 8%. And I told you before, the main problem was N2O, which bring our member from Australia saying that if you want to reduce carbon emissions, then don't focus on carbon, but focus on nitrous oxide. One point also is that the third of what a farmer emit in terms of carbon emission come from farmer suppliers, fuel or fertilization when you produce the fertilizer. And this is why one of our members said that biofuel or biogas are the best friends, even if it's used by supplier to produce this energy. So now, concretely, what can I do? What can we do as a farmer to reduce my carbon emissions? Fertilization, we've seen that the main goal would be to put less application without disturbing the yield, because as a farmer, what we want is a good yield. If you want, but you can use less application with a good yield if you use precision agriculture. If you make some rotation with pulses, this can be done with beet and with cane, and I'm very happy to have seen also in the fields next to here different rotation with sugar cane, including grams. I've not seen soy, but I've seen also different crops, which can be harvested or which cannot be harvested, just produced to reduce carbon. The post-harvest or non-burnt residues, especially for the can, can also allow you to have less fertilizers and thus to improve your carbon footprint. Then you can use different fertilizers, moving from mineral to organic fertilizer. And here, once again, in the room next to here, I've seen brilliant posters concerning organic fertilizer with compost and even vermicompost. That's mineral fertilizer. So this can be done in a proper way. And to reduce the losses in fields via the N2O, you have some enhanced efficiency fertilizers with slow release fertilization form, nitrification inhibitors, and uncoated fertilizers. This is markets that are very much emerging almost everywhere in the world. And I'm sure that in India, in coming years, you will have this kind of improved fertilizer which do not only have interest in terms of carbon farming, but only in terms of efficiency of what you apply. It's a bit more expensive when you buy it, but it's much more efficient for the plant. Then, of course, you have many things to do in terms of fuel with traffic optimization and no tillage, but I won't speak about that. And different measures can be done, especially for stop burnings, but also to keep the residues. With here big topics. If you are a farmer, you are paid according to the weight of what you deliver to the industry. So one topic would be to keep some of the leaves in your farm to improve your yield by using this biomass to produce equivalent fertilizer. The point is then that you will be less paid. So we need to find new equilibrium in shares between growers and factories. And this should be a topic that must be addressed all around the world. If we want to implement new measures by growers, they need to be paid for that. Of course, don't burn, but then sometimes you need mechanized harvest, because if growers burn the cane, it's not only because they love to burn, it's because they fear rats or snake or other animals. So they need to be replaced by something else, otherwise they won't do it. And then concerning irrigation, there is a lot to be done in solar pump. Our question was more, is this only theory, or can we make money with that? Once again, let's go back to France with the example of farm I gave you by the past. If you try to implement the easier measures to reduce carbon, then you will implement organic manure. You will use ammonitrate instead of liquid nitrogen. You will insert pulses in intercrop. Here it will be VSI. And then if you do that, you can divide your emission by 2, which is an equivalent of 2 tons of CO2 per hectare in France. But the production cost will increase by 10%. And 10%, if you take the production cost in India, it should be the same amount. If you take the production cost in India, 10% is a huge amount for a farmer, and for the moment, they will not be interested to do that. But before to go back to a more economical point of view, let's try to sequestrate. We just mentioned up to now the carbon reduction. If we want to sequestrate carbon, and nowadays, the civil society, I don't know if it's the case in India, but in many parts of the world, civil society asks the farmers to sequestrate carbon. How can you sequestrate? You can make it from cane and beet residue by soil incorporation, knowing that carbon storage is extremely limited in long term, because in the longer term, incorporate biomass in the soil will emit N2O, so it will release greenhouse gas emission. And there is now, and it comes from the UK, United Kingdom, evidence that the efficacy of practices to increase carbon sequestration is extremely limited. It can even increase carbon emissions to implement those measures. So for the moment, according to the state of the art of the technical, it's not possible to make a proper sequestration from cane and beet residue, even if there is some ongoing projects. For the moment, the main challenge is to keep on feeding the soil all around the year. Otherwise, you will lose the benefits that you can implement via the residues. We have seen it's extremely difficult to sequestrate carbon from cane and beet, but can it be done by something else than residue? Before to move to something else, we can transform those residues. It can be done via compost, we have seen it. It can also be done via biochar. And I've seen there is a poster on biochar in the room next to here. And I suggest that you go and have a look at this poster, because biochar, it's very much emerging in some countries, mainly in India, but also in Africa. And it has been very documented, and it's a very serious topic to produce biochar from the residues of cane and beet. If it's not done in a proper way, it can emit a lot of carbon, much more than what is done, but it's done also in purpose of improving the soil, which does not work in every soil, but in some soils it can indeed improve the conditions. If it is used outside the farm, keep in mind that it's another activity. And if a farmer wants to do that, he should, before implementing this, he should ask himself, is it really the most remunerative diversification for my farms? And be careful to your yield, because you can decrease your yield by implementing such practices. Something else like residues, and this is a topic that frightens a lot of your colleagues all around the world, because if you want to sequestrate carbon, maybe sugarcane and sugar beet are not the best crops. So you should maybe do something else than cane and beet. And it has been done in Ivory Coast, for instance, where farmers have been paid to sequestrate carbon, and thus they put less sugarcane on more teak forest. In Malawi, landowners may change their production to use the land in carbon sinks. And this is why our member from Sudan reminds that it's very important to consider food security as well as climate change, knowing that if carbon credits tomorrow become a new commodity, maybe one day it will be more remunerative than sugar. This is not something that can happen it can happen within a short term. I mean, it's not very long term. Carbon farming in many countries, carbon economy can begin to become a commodity, a remunerative commodity in some countries, which will have some impact in other countries. So then on this, we'll close my presentation focusing on economy. Why should a farmer make some carbon farming? He will do it only because a third party can pay for doing it. Otherwise, he won't do it. As I told you, it's costly, 10% of your production cost. For the moment, it is not remunerative. You have some examples in Sweden, in Belgium, mainly in Europe, but also in Australia, where you can be paid to make some carbon farming, but it's not so remunerative. And it will become harder and harder because slowly by slowly, there is some certification on carbon farming to prevent greenwashings, with a challenge to consider simplicity, to have a simple way to be certified, but also control to make sure that you are not paid twice for one effort that you can make. This can be summarized by what I've replied our member from Mexico. Farmers should not consider income from carbon credit as part of their financial analysis. Or from your colleague in Belize, in South America, fears that small-scale farmers won't benefit from those schemes that can only be achievable by big structure. And I keep in mind that in many countries, sugarcane are grown by factories. It's the case, for instance, in Brazil. And sometimes it's much more easy to improve your practice if you are big groups than if you are a small-scale farmer. The competition will be hard, and slowly by slowly we will move towards international rules to create it. This is the first part. So a farmer can be paid by a third party, but it can also be paid by the buyers. But your buyers, the sugar factories, especially even in India, and especially if they want to go to the world market, they will have to prove they make some effort in terms of carbon emission reduction. And then if he will have to do this, I'm not sure he will pay for that because it will become mandatory. And in my career, I do not have any example of something mandatory which is extra paid in the long term. So on my views, if it's mandatory, it will not be paid to the growers. And this has been replied by our member from Australia, who says that the market may support methodologies that may reduce greenhouse gas emission, but that will also reduce sugarcane production. In the UK, take only into consideration the cost of the measures, but not the impact on the yield. That should also be paid to the growers, but this will probably never be paid, with an increased risk of dependence of individual farmers from big agro-industry companies. But maybe if farmers will change their practices within the next 10 years, it will also be because they will have to. And well, it has been mentioned concerning, for instance, the burning of the cane. If people reduce the burning of the cane, it's because they have to, and they rarely have extra money for that around the world. Many states have a goal in terms of greenhouse gas reduction, and this goal can be fixed by law or not. And they will have to take measures to achieve it. And some farmers, anyway, will be prohibited from participating if they do not adopt some practices, not only in industry, but also in the finance sector. It can also be a mix, and I have a good example in Brazil with the Renovabio program. Renovabio program, I won't detail it, But it's a very interesting program because it's something that it is mandatory, but that is paid by the consumers, focusing on ethanol, mandatory by law, but paid by the consumers. But then you cannot be extra paid by something else. And if the farmers do not receive share of their effort, then it won't be sustainable. And it is why our member from Brazil would like to receive their share for this effort. So to conclude my presentation, carbon farming is a vast subject that has been widely studied by many growers associations around the world. First, because it can be a source of income from the growers. And some examples show that it can exist all around the world, although legal ongoing frameworks may minimize it in the coming years. And then farmers associations have interest in carbon farming because they fear that it will become mandatory. It can be mandatory by law or by commercial rules. And this will certainly impact our production costs. And this will certainly impact the yields. Tomorrow, this is the equation to recall the potentiality of our production to reduce fossil CO2 emissions, because in fact, what the civil society maybe want is not that we reduce our carbon emission, but that we reduce our fossil carbon emissions. This can be done via ethanol and green chemistry, but also to encourage new outlets, including from our byproducts, bagasse in sugarcane or pulp in the sugar beet. All for that, to conclude, this message is that slowly by slowly, we are moving with new equilibrium between the products, sugar, ethanol, but also with co-products, pulp and bagasse, that need to be anticipated. Sugarcane growers, you have something very powerful in your hand, which is a bagasse, and this would make sense that you receive a part of what is done with the bagasse. And more widely, we should move towards new ways to valorize our production, not directly linked to commercial yields, but also for the services that we can give to the society. And this will conclude my speech. Thank you very much.
Thank you, Timothy, for nice presentation. And I would like to invite our next speaker, Mr. Richard Savage, and he will speak on the advantage of the beet sugar factory compared to the cane sugar factory.
After completion of talk of all the speakers, we can go for question and answering. So our next speaker is Mr. Richard Savage, and also Mr. Fabian Mazurek also contribute in this talk. So Mr. Richard did his master's in business administration and vast experience in industrial processing of sugarcane and sugar beet, and is currently working as a responsible commercial at Maguen, France, and he is going to deliver his talk on advantages of beet sugar industry compared to cane sugar factory. So I would request Mr. Richard Savage to deliver his talk.
Hello, everyone. I hope you are happy to be here, because me, I am very happy to be here and have this opportunity to present our company. First of all, thanks to Dr. Solomon, and thanks to Dr. Prati and SVI for this organization. The presentation is the advantage of the beet sugar factory compared to the cane sugar factory. So my name is Richard Sauvage. I am a sales manager for Maguen in France. And before the presentation of Fabien Majrac, please let me introduce my company Maguen to you. Magan has been offering a complete range of industrial services and equipment for over 185 years, whether as part of a global offer or a more specific services. Magan designs, engineering, manufactures, delivers, erection, assemblies, supervisor and control, commissioning, and assists its customer throughout the world and after the completion of the industrial projects. Magan SS specialties for beet sugar factory. We have other specialties, but we speak here about beet sugar factory. And we have more than 180 years experience in beet handling. We have the know for the beet unloading and the beet storage, the beet washing, the beet slicing, juice extraction, the lime kilns and milk of lime preparation. If you want to produce sugar, if you want just to produce alcohol, this plant is not necessary. And also we have the know for the pulp drying and pelletizing with Magan Promil, or you can, for the drying, use the sun, like some countries. Subject of our presence after the presentation of Magan, so that you know a little bit more our company, but we will stay available, of course, after this presentation. Subject of our presence is this international conference. The purpose is to give you some data, very important, some data of the beet sugar factory, and to compare, thanks to you, the beet sugar factory to the cane sugar factory. Now let me introduce Fabien Maïchak, who is going to make our presentation, because I have not enough know for that. So, please, Fabien.
Okay, thank you, Richard. So first, let's see what you get from 1 hectare of beet and cane. So as it has been told before, the beet yield is a little bit better than the cane yield, and with higher sugar content. So you get more sugar from beets than from cane, but at the cost of less fiber production, because with cane, obviously, you got a lot of bagasse that is used to produce energy. The ratio is something about 3,000 kilowatt per ton of sugar. With the beet, the fiber has a different use. It's mainly used today for cattle feed. You get something like 30 tons of animal feed at 30% dry substance that can be used directly out of the sugar factory, or you can dry it. But we will talk about it later. Some European factories start to dry their pulp and use it as energy supply for their boilers. And you can achieve, as for cane, energy independence for your sugar factory. The specificity of the sugar beet compared to cane is where is the sugar. The sugar in the sugar juice in the sugar beet is inside the cell here, and when the beet is out of the field, the sugar cannot be extracted. But thanks to the action of temperature, this membrane here is permeable, and the sugar can be extracted via osmosis. The interest of this is that the sugar juice is extracted through the sugar cell, the beet cell. This allows to retain inside the cell the high molecular weight molecules, and you get a higher purity juice thanks to these techniques. In fact, the extraction of juice and the cell itself is the first step of the purification of the juice. So the general process flow, so I compare in orange, it's the cane, you crush, you extract by diffuser or mill, and you make a slight purification before evaporation and crystallization. With the sugar beet, the first step is to wash, because the sugar beet is a root, so the main part of the plant is in the soil. So when you recover the beet, it's covered with soil and also with stones, leaves that need to be removed to be processed. Then there is a slicing. It's a little bit different than crushing. Extraction only by diffuser. We cannot press like in a mill. And then an extensive purification before evaporation and crystallization. The result is molasses, the same as in cane, and direct white sugar and not brown sugar like from cane. So the beets have to be washed to avoid the wearing of the slicer and the knives, and also to avoid to send soil in the juice to the purification system. So there are different steps of washing. With each step has a purpose to separate the soil, separate the stones, separate the leaves. And there is no use of fresh water. All the water is reused in a closed loop with cleaning of the water, and we use water from the pit that we recover. So there is no fresh and clean water used for that. It's a total recycling of the water. The soil, the stones, and the weeds that are recovered from the washing station can be used for different purposes, for animal feed, for construction, to make path, and to send back the soil to the field. So the slicing is very specific. As sugar juice is filtered through the cell membrane, we don't want to crush the beets. We want the beet cells to stay as intact, as complete as possible, and we don't crush, but we carefully slice the beets to retain as much impurities as possible inside the cell. Slicing is the first step of the purification. So we use very specific knives with a V shape to produce what we call cossets. It's like a French fry, but with a V shape and not a square shape. And this allows to have the maximum exchange surface to extract the juice and the sugar with stronger products and less damage to the beets. Of course, with the equipment, the slicer, comes the equipment to make the maintenance of the knives. The knives can be used several times, up to 10 to 15 times. So the next step is extraction. So we can use the Smet belt diffusers like it's used in some cane factories around the world, but the top technology today, the modern technology that is installed everywhere in beet regions, is the tower diffuser here. The tower diffuser has a very efficient technology, giving a very low draft, as low as 103% on beets, with very low sugar losses in the pulp, only 1.6% losses of sugar. It produces a cold juice around 10 to 15 degrees more than the beets only, so very small energy usage, and it allows to energy recovery from condensate or from pan vapor, pan steam, to heat the juice for free. Then the purification. In cane sugar production, the purification is only what we call in the beets the first liming, the pre-liming, to remove the proteins. But for sugar beet, we make a two-step purification with the pre-liming, but with then a massive liming followed by carbonation. I will explain after that why we do this. After this first carbonation, we separate the lime that is sent to desugarization. This wash lime, as in cane, can be used in the fields and for different purposes. So it's also recycled, it's not a waste. And then we do a second carbonation to remove the excess of lime, and it can also be followed by juice softening on the resin beds. The specificity of the liming and carbonation step is that improves settling and filtration. In sugarcane production, after the liming, you need to have something like 1 hour of settling, because the mud that you produce with the lime is a very low quality and the settling time is very long. This long residence time in the settling produce a lot of reducing sugars and a lot of sugar losses and color formation. So this is the first interest. Second interest is that the massive liming destroys the reducing sugar and helps to capture and prevent color formation. So this is why from sugar beet, thanks to the main liming and carbonation, we get the direct white sugar. This is the same steps that are done to refine brown sugar, because brown sugar is melted and limed and followed by carbonation. But when you produce the sugar from cane, you produce a lot of very hard to remove, very brown colors. And with the beet purification process, you remove the reducing sugars and you remove the color as soon as possible when it's easier. So it's more efficient. It also prevents the fouling of evaporators because you have less particles and less acids like tartric acid and oxalate. And this means that a beet sugar factory can work for 130, 150 days straight without any evaporation cleaning. So this is of a big interest because you don't need to have the double surface of evaporation to allow cleaning every weeks, 2 weeks, 3 weeks. So of course, it requires a larger amount of lime. So you need to install a lime kiln inside the factory. So you process directly limestone. There are also possibilities to use external produced lime and to do the carbonation with, for example, exhaust gases from the boiler, and thus you make carbon capture thanks to the factory. So we are talking about sustainable activity and carbon. So this is a way to capture the carbon with the carbonation of the lime. So let's talk about the fiber now. The beet pulp can be used for traditionally animal feed as a low dry substance product for a very local use, or high dry substance pellets after drying and after pelletizing. And this allows you a long time storage and easy transport. The interest of cattle feed is that it's locally produced and it avoids you to grow, for example, soy or sunflower or other products to feed the animals. So you save soil surface for animal feed, or it avoids to import from other countries. So it's an interest for your commercial balance of the country. But as I told you, some factories in France, notably, starts to use this pulp as energy production, because we have less and less cattle in France, and in some regions we don't have. So they need to dry the pulp and to send it abroad for another consumer. But they decide now to use locally their dry pulp for energy production. And to do this, the beet sugar pulp is dried for free with techniques like steam drying, belt drying, and in tropical countries they can even do sun drying. And then all the energy from the pulp is recovered as high as 800 kilowatt per ton of sugar. And this is today the consumption of the sugar factory in Europe. So this means that beet sugar factories can also be energy sufficient with their fiber. So if we make a small conclusion of the comparison, we know that the beet, and it has been told by previous speakers, beet is more tolerant to salinity, to frost, to drought. It uses less water. For example, it's 3 times less water per year in Northern Africa countries where we work. I have also seen a poster giving the same numbers here for India. You produce more sugar per hectare. You can produce direct white sugar. You have less falling of your equipment, and notably evaporation and crystallization. and you have the opportunity to produce either animal feed or be self-sufficient on energy. All advantages have disadvantages, and for sure, cane has its advantages. You can produce more energy from bagasse because you produce more fiber. You don't have to seed every year, but you need to, every 3, 4, 5, 6, 10 years, make a new planting. So it has also its disadvantages. And of course, can use less lime. But the idea is not to replace cane from beets. We don't want India to go fully to 100% of beets. The idea, as it has been taught before, is a complementary use of beet and cane. If you have a cane factory, you have a cane yard, you have a cane mill and or a diffuser, and then you have your process building. And this is also the same with ethanol production. And if you want to produce beet sugar, sugar beet in a cane sugar factory, you only have to add the beet handling with the beet yard, the washing plant, and the slicing plant. And if you already have a belt diffuser, you can use it. And if not, you can add the tower diffuser or invest on a belt diffuser that can be used during the cane season and during the beet season. Because the big interest is that the season of the two crops are not at the same time. So if you use cane and beets in the same factory, you extend the production time of your factory. So this means with the same tools, evaporation and crystallization, you produce more sugar per year during more time. So it's a better return on investment or your factory. And then, if you want to produce sugar, you need the lime kiln, you need to extend the purification process, and you need to dry your pulp. But of course, if the goal is to produce only ethanol, you don't have to put the lime kiln, and you don't have to extend the purification process. You can produce ethanol directly from the beet juice after the diffuser. And thank you for listening to my presentation. And I think after that, we will have all the questions.
Thank you very much. All our speakers have finished their presentation. And if there is any question regarding sugar beet, any aspect of sugar beet production, seed production, processing, and how one can integrate with the cane. So you are most welcome. We can take 2 or 3 questions. Please.
Sir, in UP, during winter season, during autumn sugarcane planting, most of the farmers use in crop mustard and potato. In major area of the sugarcane, mustard and potato is being used as intercrop. So this sugar beet, how it will compete to mustard as well as potato? Is it much profitable than potato and mustard? Anybody can answer?
Hello. Thank you for your question. Actually, sugarcane intercropping with potato is a very common, as you told, it is very common in Eastern UP and Bihar. And it is more profitable. Last past few decades. Now people convert another crop, taking another crop as an intercrop in sugarcane, like you told the mustard. But you see, mustard is not economical because a mustard intercrop with sugarcane is not economical because it hampers the sugarcane yield like anything. Secondly, you asked how it will beneficial if you go with the sugar beet as intercrop with the autumn planting of sugarcane. So my suggestion is that here you are growing another sugar crop, and you will help the sugar industry to milling to extend the milling up to 2 to 3 months. So by that way, you will get more earning with the intercropping, and the sugar industry will run with the same maintenance cost. Thank you.
From the farmer's point of view, I'm asking, not for the sugar industry
Sir,
point of view.
I am asking that intercropping is always beneficial for the farmers. Even in with the sugar beet, you will if you go solo sugar cane, you will harvest. And you are from UP?
I'm from UP. I'm asking about the autumn sugarcane planting.
Actually,
during autumn, most of the farmers use potato as well as mustard. So is it potato and mustard is more profitable, or your sugar beet is profitable in comparison?
Sugar beet will be profitable because you will harvest nearly 65 ton per hectare sugar cane, and nearly 45 ton per hectare sugar beet.
Thank you.
Okay, thank you.
Sorry, I have a question for Mr. Evrard and even Mr. Moll. I'm Regis Goebel from CIRAD, from France, in Montpellier. And I would like to ask you about the herbicide, because you were talking about herbicide to control weeds, and I would like to know if you have other alternative, like agroecological management, use of cover crops, etc., etc. And even for Spodoptera, do you use pesticide, or you have alternative like biocontrol or any kind of ecological way? Thanks.
Okay, your question is about weed control, herbicide.
Weed control and insect control, pest control as well.
But weed control, as you know, we have some limitation in EU to use some weed control. We still have some in India. Metamitron is still existing in India. We're able to control the weed here. But it's still difficult to find the right weed control in India today. We know that in Punjab, Rana is still using some weed control, which is working. You have seen some pictures, the fields are quite clean. About disease control, Cercospora, the same difficulty also to find the right product. But you have seen that could be possible to find some, I don't know the active ingredient of this product, but it's still possible to find some disease control product in India as well, but not so many, I would to say.
Are you going to do some research in terms of cover crops, for example, to control the weeds, or there is no...
Vous pouvez dire en français, j'ai pas compris, je suis désolé.
Yeah, no, you use cover crop like a companion plant to cover the weeds. And we used to use that in sugarcane. It works quite well. So I would like to know if the beets, the beet, for example, if you use this type of technology or not. Les plantes de couverture.
It's already difficult to find the good cover crop to limit the weed to push. I mean, the sugar beet by itself went, but at the beginning of the crop, the difficulty will be to have the right time. Yeah.
And maybe one extra information also, cover crop in sugar beet, I think it has been never done for wheat.
Yeah.
It has been done for fighting aphids or beetle with barley, avoine, but it has been shown that at the very beginning it's quite good, but the more you go in the crop, the less you have some benefit, because very soon it will compete with sugar beet.
Okay. Thank you.
Sir, for carver farming, for for carbon farming, which decomposing bacteria are useful or not? Decomposing bacteria are useful for carbon farming or not?
Is it composting or is it bacteria? Bacteria that you put in the fields, that's it?
For decomposting of sugarcane trash, it is useful for carbon farming or not?
On technical points, I'm not sure to be the best man to reply on compost technology, but I'm sure you have some poster over there and you can find people who can reply to you. I won't be of good help. What I know is that when some people do some compost, quite often they don't add anything more. Maybe it can accelerate, but I don't have the exact amount of time and value for that. I don't know.
Thank you.
Any other question from the audience?
This question is to Dr. Mal. Most of the research stations mentioned were in high altitude in Uttarakhand and others, over 5,000 feet. Have you developed any indigenous seed varieties suitable for the plains or for lower altitude, this thing?
Firstly, I want to clarify that I have mentioned 5 to 6 places. That places identified by ISR for the better seed production only. Now we have run a center at Mukteswar only. The second question I couldn't get you. Can you ask me again, sir?
Any varieties, any indigenous varieties which are good and suitable for the plain areas, for lower altitude plain areas?
Yes, sir. We have identified several genotypes for the different characteristics with high root yield and juice quality. Sir, later I will give you the detail. Actually, one slide missed here. I'm really sorry, but we have identified 10 to 14 genotypes for different characteristics. Even, sir, we have identified low bricks genotype for the fodder purpose actually. And for the earlier speaker mentioned that the post-harvest deterioration is the key challenges for the sugar beet. We have identified 2 to 3 genotypes which shown less deterioration other than the other varieties. So I will give you the details, sir. Okay, thank you.
I have a question, Amal sir, that you have rigorously worked on sugar beet. So have you reported white grub in sugar beet at the time of research work?
So at my place, I never seen the white grub in sugar beet. Spodoptera luteira is the major insect pest. And even sometimes after a Rabi crop harvest, different insect pests invade like anything, because the only sugar beet is the green crop at the time. Thank you.
Thank you, sir. Anybody?
Sorry again, it's me. Very interesting talk, the last talk comparing the sugarcane and beet. But I'm just wondering why the point to compare the different crops, because we know that the sugar from sugar beet is about 20%, the sugarcane is 80%. Or your talk is to encourage the farmers to grow more sugar beet, or what is the idea behind this talk?
The idea is that, for example, we know that now there are restrictions for the use of sugarcane to produce ethanol. So, for example, it's an idea to use sugarcane here in India to produce ethanol. It's also, I've not focused a lot on that because it has been told before, but the interest of sugar beet in India is that it's more resistant to salinity, it needs less water, so it can solve some, give some solutions to some problems in some regions. I don't say that sugar beet is the must-have solution for all India, but it can bring solution where the cane is not suitable anymore due to salinity, due to the extensive use of water, and there is it can be an interest. We have seen also pictures of combined growing of cane and beet on the same field. In advantage of beet in the crop rotation, we talk about potato, etc. So it's more about what the beet can give you as solution to the problems you have with cane today, and maybe switch from cane to beet for some of these problems, or extend the surface with beets to produce and cane and beet and produce in the end more sugar.
Also, in a cane sugar factory, you have the workers, and if you had a beet sugar campaign with the same workers, so you can extend the day of the campaign and to produce alcohol thanks to the beets and sugar thanks to the can. We think it's very interesting solution to win money.
Just a quick comment. It's interesting what you say, because I think we can say that is like a flexible, flex crops, and which is an advantage, I think. Yeah, it's a big advantage of that type of crop. Thanks.
Any other comments from the audience? Questions?
Sir, one more. Good. Hello. This is a question from the farmer side. Due to the plantation of the sugar cane from the number of years, and due to the it takes the yield low because soil has taken the erosion level for the high. For that purpose, my question is from the farmer side, how can we increase the yield in per acre from the sugar cane?
Your income is based on the yield, but also on the price of the crop, and also of the cost of production. So you don't have only to increase your yield, you have also to fight for a good price, and you have also to fight to find a way to reduce cost of production. And reducing cost of production as well as improving yield, I think this is maybe the reason of your presence here too, because this can be done via investment in terms of knowledge. And once again, I've been in the poster area. You have many ways to increase yield and to decrease cost of production. One of the best examples nowadays in the world, I think, come from Brazil, and it has been designed over there. We can see in the fields, is this intercropping with pulses, intercropping with grams, black grams, intercroppings with soybean in Brazil. It's very much interesting because it can decrease your cost of production in terms of fertilization. It can include new revenue from new crops that you can change from year to year. One year it can be gram, the other year it can be cabbage. I saw cabbage, I never saw cabbage, or marigold even. I've never seen that before. And this is also interesting because so that you don't have to plant new varieties in the entire rows, but only in 2 rows out of 10 rows. And in Brazil, it began, I think, 10 or 12 years ago, and now it's very common and everybody do that because it decreased the cost of production. I think one of the most important thing for farmers is not just to try to have the better yield, it's also to decrease your cost of production.
Thank you. One more question from this side, please. Wait.
Yes, sir. My question is regarding sugar beet breeding. Mainly sugar beet production, seed production is on hilly area. But can we make some planning in plain area for the seed production?
Hello. I already told that we have ISR identified 5 to 6 places for the seed production. There is a need of cold temperature. So at plain area, you cannot get flowering, especially in sugar beet. Thank you.
Sir, in Maharashtra, Mahabaleshwar, like some
No,
places
no.
like Maharashtra.
Actually, I already told you that the process of vernalization and cold treatment is necessary for the seed production of sugar beet. So here, if you anyhow you will get the flowering, but flower may not fertile.
It may be seeds, sterile seeds are there.
That is the major constraints of the sugar beet cultivation actually.
Okay.
Thank you.
Thank you, sir.
I think if there is no more questions, then I would like to thank all my speakers. But before, just few things which I would like to share about this session is in this presentation, much of the emphasis was on getting good varieties of sugar beet, especially for tropical condition. We have tried in the past in India, and we do have the experience of growing sugar beet in Punjab and Maharashtra. My friends have shared his experience. We have around 7,000 hectares in Punjab, and they are growing sugar beet. So the emphasis on how to get beet with good yield and high sugar content and resistance to multiple stress, especially all disease and pest which are damaging the sugar beet. How to integrate the beet cultivation with cane? There are number of experiments which have been done in different institutes, and VSI also, in Indian Institute of Sugarcane also, and we have established that this can be grown separately or in combination as an intercrop. Some good questions have come. So we have to really find out what kind of the agro-technology is useful, so there is no yield on the compromise, either cane or beet. Some of the things which has prevented the beet cultivation in India is about how to get the additional fuel for sugar beet processing. I recollect there was a sugar beet factory, dual factory. It was cane and beet factory in Shri Ganganagar, Rajasthan. Good beet used to grow, but that has to be closed down. It's not because of that we don't have the technology, but there was some other reason for that. But these areas are good for beet cultivation. Then we have to look how we can minimize the post-harvest losses in sugar beet. There were, even we were doing experiments, there was a report that a lot of sugar is lost because of the transit losses. And still, if I recollect, there's no pricing policy for sugar beet. We have pricing policy for cane, but not for sugar beets. So far from farmers' point of view or industry point of view, we have to, if we have to take forward this crop, we have to really think about these few issues. And some good varieties exist with us. Dr. Mal has shared. These LS6 and IISR compound, they are good varieties developed by our institute. And we are upscaling the facilities at Mukuteshwar and also at other 5 locations. So seed production and seed availability will be no problem in future. And what is really needed is that some investment from industry should come up for encouraging the beet cultivation, especially in subtropical India where the temperature is desirable for both cane and wheat. So I thank all my speakers who have come so far to share their experience on sugar beet with us. Thank you so much. And also thank you for staying with us. Thank you, and also thank our rapporteur for doing good work. Thank you so much.
Thank you to our esteemed chairman, our speakers, Mr. Everard sir, Dr. Mal sir, Mr. Masson, Mr. Savage, and Mr. Fabian. So at the end, as a token of appreciation, we felicitate our speakers and chairman by giving a memento. So I would like to request our chairman to honor Mr. Everard sir by giving a memento. Yeah, I request Chairman sir to honor a memento to Dr. Mal. Yeah, again I request Chairman sir to honor a memento to Mr. Timothy Masson. Yeah, I request the Chairman sir to award a memento to Richard Savage and Fabian Mazrak. So I request our principal scientist, Dr. A.D. Kadlak sir, to present a memento to our chairman, Dr. Solomon sir. Yeah, at the end, I extend my heartfelt thanks to all the speaker and panelists who shared their knowledge and experiences. I sincerely thanks to all the attendees, organizers and supporters who made this session a truly enriching experiences. And with the due permission of session chairman, I declare that the session is ended. Thank you. So after a short tea break, next session on technical provider session will start at 5 p.m. Thank you.
Hello. In a technology provider session, please be attend Indian Farmer Fertilizer Corporative Limited, Sri Datta Shiro SSK Limited, and the Maharashtra State Chemist and Druggist Association. Please. वाचलं की पहिलंच एक नंबर. For this, please. Within a 5 minutes, the session will be the start. Please attend it after the tea break. This is a technical provider session, and on these topics, I firstly invited to the session chairman, Professor P.P. Shinde sir, chairman of this technical provider session. Then I also invite to Mr. B.H. Pawar sir, co-chairman of this session. Then speakers, IFCO, Dattashiro Heganna sir, please. Okay. Maharashtra Drug Association, then in the Dattashiro, the Patil sir is also present. Dattashiro, Patil sir. Maharashtra Drug Association, anybody present here? Maharashtra Drug Association? Please. Okay. नमस्ते. सर तुम्हालाही I cordially invited to Shinde sir for introductory remarks.
Good afternoon. I welcome all the delegates for this technology provider session. Myself, P.P. Shinde, I am chairing this session, and Mr. B.H. Pawar from VSI, he is co-chairman for this session. Sri Ganpatrao Patil, chairman of Datta Sugar Mill. They have done a very good work about the subsurface drainage work in their area of operation. He is also present for the, I welcome him for this session. There are two speakers. One presentation that will be by the IPCO, because nano urea, it is the upcoming subject, and he will give the information about this use of the nano urea in sugarcane cultivation and other crops. And Mr. Heganna, Chief Agriculture Officer of the Datta Sugar Mill, he will give the information about the success story of the subsurface drainage work carried out at their sugar mill. So I will request first presenter, that is a IPCO company representative Sri Pawar, to give his brief introduction and start the presentation. Mr. Pawar.
Respected Chairman, Co-Chairman, Chairman of Sakar Karkhana, Dada, who is our IPCO RGB member also, then Heganna, and all farmers' friends. Myself, Dr. M.S. Pawar, working as a Senior Manager Marketing in Indian Farmers Fertilizers Cooperative Limited, that is IFCO. I am going to present regarding the two nano fertilizers, that is the nano DAP and nano urea, which is a newly invented product by IFCO. So I'll give in brief information regarding these fertilizers. So these two fertilizers is developed by IFCO, which is the world largest cooperative, which is established 57 years back with 57 societies, and now we have got the network of more than 35,000 societies all over India, and we are marketing around 135 lakh tons of fertilizer in India, and it contributes about 20% nitrogen and 32% phosphatic fertilizers. And IFCO is not a single organization. We have got around 21 joint ventures as per the need of farmers. And we are giving 20% dividend and some Sankat Haran Bima Yojana for fertilizers and pesticide also. So these are our traditional products, right from urea, DAP, then complex fertilizers, then we have brought water-soluble fertilizers, secondary nutrients, then we have brought biofertilizers. So after this, we have brought two innovative products, that is the one nano fertilizers, nano urea, nano DAP, and biostimulant that is named as a Sagarika. So in short, we will discuss about the nano fertilizers. So as you know that fertilizers plays important role in the agriculture production, and its contribution is around 50%. So we cannot neglect fertilizers, because if we see the fertilizer consumption and its food grain production, there is linear relationship. As the fertilizer consumption increases, our food grain production also increases. But recently, there are number of reports from the all corners of our country that in spite of increasing the inputs in agriculture, our production is decreasing. Once upon a time in the year 75, application of 1 kg NPK results into 15 kg of food grain production, and now it is declined, it has come to 5 kg. So there are number of issues in Indian agriculture, that is the deterioration of soil organic stock, deterioration of environmental quality, disparity in fertilizer consumption, then low fertility status, low fertilizer use efficiency, imbalance in NPK ratio, and it all together leads to the sustainability. So that is why our production per capita or per unit is decreasing. So coming to fertilizer consumption, in year 2020-21, we have consumed around 661 lakh tons of fertilizers. Out of that, urea alone is 350 lakh tons. That is the, out of total fertilizer consumption, urea contributes around 53%, followed by DAP around 105 lakh tons, all complex put together 121 lakh tons, then MOP are around 35 lakh tons, and SSP around 50 lakh tons. So that means we are consuming urea more than 53% out of total fertilizer consumption, and that is 350 lakh tons. So coming to the fertilizer use efficiency, our use efficiency is also again very low. In case of nitrogen, it is around 30 to 40%, phosphorus it is around 50%, and potash it is around 50%. So that is why our Prime Minister is also appealing for reduction of chemical fertilizers consumption, especially urea, by 50%. And we know that these fertilizers or the raw material is not available in India. So make the fertilizers available in affordable cost to the farmer. Government of India is giving subsidy to all these kinds of fertilizers, and it is under the NBS, that is nutrient-based subsidy. But urea is totally controlled by the Department of Fertilizers, Government of India, and it is not included in the NBS. And on an average, government is paying 1.20 lakh crores of subsidy to make these fertilizers available in India. But last year, because of the Russia-Ukraine Yuddha, the amount was 2.5 lakh crores. So why I am telling that these fertilizers are not available, we have to brought from the either raw material or finished product, we have to brought from the other countries. So coming to the nitrogen, nitrogen is a major element which is required for the protein synthesis, carbohydrate, and most important, it required for the chlorophyll, which plays important role in the photosynthesis. Then amino acids, and it is required also for genetic material like RNA and DNA. And in India, we use urea as a major source to supply nitrogen to the plants, but its efficiency is around 30%, and 70% urea leads to air pollution, soil pollution, and water pollution. And hence, there is urgent need to go for option of the urea, because we are giving huge subsidy. Again, its efficiency is only 30%, and 70% what is going waste, it is causing the natural resources deterioration. And if you see the history of human beings, there are many revolutions from the beginning, like textile, railways, automobiles, computer, and the present era is of nanotechnology. Nanotechnology already used in medical sciences, engineering, and now it is a time to use in agriculture. And Indian Farmers Fertilizer, that is called IFCO, has brought 2 nano fertilizers, that is the nano urea and nano DAP. So what is nano fertilizers? So nano fertilizer is nothing but it contains the nutrient in particle size having size 20 to 50 nanometer. It is top to bottom concept that is going towards the small and small size, and the nanoparticles, nutrients will be in the nanoparticles having the size 20 to 50 nanometer. That is compared to conventional fertilizers, 1 gram or 1 granular is equal to 55,000 of nanoparticles. And because of that, it has 10,000 times more surface area And if the surface area increases, automatically the use efficiency increases. And these small tiny particles easily enter through the stomatas and other openings, and it provides the nutrition requirement to the plant very effectively. Coming to the how understand the size of nanometer, I have given here some examples. The human ear, the girth is around 1 lakh nanometer. Coronavirus, we know that about the coronavirus, the size of coronavirus is 60 nanometer, while that of nanofertilizer it is around 32 nanometers. So it is 50% of the coronavirus, and we know because of the size only, coronavirus spread all over the world, and it was very difficult to control the coronavirus because of its size. It was the power. Then these nanoparticles are specially designed for foliar application only. After application, it will be absorbed through the stomatas, through the epicuticular layer. Then it will move through the phloem mechanism. Generally, conventional fertilizers will be absorbed through the xylem along with the water, while these fertilizers will move through the phloem, and after absorption to the plant, it will be used as per the requirement of the plant. So this is the basic difference between the conventional fertilizer and nano fertilizers. Then it has got higher use efficiency because it is applied through the foliar root. Foliar root in the form of nano fertilizers or nano form, then it is overcome the epicutical wax barrier, and because of low surface tension with the desirable contact angle, it is absorbed very easily, and it is the more number of urea molecules or amide particles are available for the entry and metabolism at a given point compared to the conventional urea. And it is the nano fertilizers place, or the game starts with the size and number. The object was to develop advanced nano fertilizers with better nutrient efficiency, to reduce the imbalance and indiscriminate use of fertilizers, to increase the crop productivity and quality also, and to address the issues of soil, air, and water pollution. So this is the object behind the development of nano urea and nano fertilizers, and it found that it reduces the input cost, it improves the productivity, it is very easy for transportation and storage also, and it will reduce the import of fertilizer if we use on a large scale. Then application benefits of nano fertilizer, it is a power packed formulation with number and size. As I told, it is a nanoparticles, hence per area or per unit more nano or this amide molecules are available as compared to the conventional urea. Then it has got better nutrient delivery system. Then it is spread on the leaf surface. It activates the leaf surface because of some stimulants are there, and it activates the leaf surface and foliage also. Then it is a dynamic chlorophyll charger. Because of use of nano fertilizers, we have got number of experiments that increases the chlorophyll content also. And it also acts as a homeostasis, means it tolerates the stress also. And because of nano fertilizer, there is less lodging of crop. Then it has got higher use efficiency, better source to sink relationship. It also increases the photosynthetic efficiency, and because of all activity, it gives higher yield compared to our conventional fertilizers. Then these are the two notifications issued by Government of India, that is the nano urea and nano DAP, and it is comes under the FCO, fertilizer control order. Nano urea contains 4% nitrogen, while nano DAP contains 8% nitrogen and 16% phosphorus. So regarding specification of nano urea, it contains 4% nitrogen, but as per FCO, it varies from 1 to 5%. Then particle size 20 to 50 nanometer. Hydrodynamic means after putting into the water, the size should be 20 to 80 nanometer, less than 100 nanometer, and it has got good zeta potential, viscosity, and pH 2. Then its application in normal crops, we recommend 2 application or 2 sprays of nano urea, while in case of sugarcane, we are recommending 3 sprays of nano urea at 45 to 60 days after transplanting, 75 to 80 days after transplanting, and 100 to 110 days after transplanting. These three sprays we are recommending for the sugarcane because it is a annual crop. Coming to the nano DAP, it contains nitrogen 7 to 9%, phosphorus 15 to 17%. It has also got good nanoparticle properties like particle size, hydrodynamic size, zeta potential, pH, viscosity. Then application of nano DAP, we can apply nano DAP in two forms. First is two methods. First is in case of sugarcane, set treatment, and again foliar spray. So for set treatment, we have to put nano DAP 3 to 5 ml per liter of water. Then we have to keep the sets for 15 to 20 minutes in the solution, and then after drying into set, we have to use that for the plantation. And in case of nano DAP spraying, we can go for two sprays at 2 to 4 ml per liter of water at tillering stage and at grand growth stage. So these two spray we can take of nano DAP. Then this nano urea, nano DAP, it requires less, it produces more, it is economically affordable, and it is bioecologically very safe. It doesn't causes any harmful effect on soil, air, and environment. And it is evaluated at ICR labs and DBT labs. Then there may be one question in the farmer's mind that if it is the application is through foliar, then why not for conventional urea? But in case of conventional urea, after putting the conventional urea into the water, then the molecules like carbon, hydrogen, oxygen, which is available in the urea, they come out and they form the network. And the network of that, this one dissolved material is around 10,000 nanometer. While in case of nano urea, we have put one polymer protectant on the nanoparticles. Because of that, that molecules remain as such. They will not come out after putting into the water, and hence that will remain 25 nanometer only. They will not go for 1,000 or 10,000 nanometers. And hence, it is easily absorbed to the plant. And in case of conventional urea, if you spray on the plant, there are chances of phototoxicity. But in case of nano urea, there is no chances of phototoxicity, and it gives quick response, and it is a very useful as compared to the conventional urea. So this is one of the study on the rice crop. They have applied conventional urea through soil. They have applied conventional urea through soil as well as foliar application, and they have applied nano urea in last column. So they found that all the three stages, vegetative, tillering, and booting, chlorophyll content increases because of application of nano urea compared to the conventional urea. So this is one of the study at Tamil Nadu Agriculture University. They shows that all amino acid content increased as compared to the conventional urea where nano urea is applied. Then this is again study at Tamil Nadu Agriculture University. All enzymes which is required for the nitrogen assimilation are increased with application of nano urea compared to the conventional urea. And in case of maize, they have studied chlorophyll content by using SPAD, that is one of the instrument which measures the chlorophyll content of the plant. So in all vegetative tasseling and harvesting stage, chlorophyll content increased with application of nano urea compared to conventional urea. So these are the trials right now going at Mahatma Phule Krishi Vidyapit Rahuri on cotton, maize, and sugarcane also. So this is our Nano Biotechnology Research Center at Kalol, Gujarat. Then we have conducted trials at 22 ICR research institutes on 13 major crops at 43 locations. And simultaneously, we have on IFCO's behalf, we have conducted 11,000 farmers field trials on 91 crops. And on this basis, Government of India has approved these two products and permitted brought into the FCO. So these are the trials we have conducted right from Jammu Kashmir to Kanyakumari and from Gujarat to Assam. And on an average, it founds application of nano urea and nano DAP increases yield by 7 to 8%. And these are the various trials on major crops where we have conducted trials almost all crops our country. We have conducted the trials. So this is the one of the 3 years data of MPKV Rahuri. We have conducted trial on sugarcane crops. So there are 3 treatments. There are 9 treatments, but the comparison I have taken here 3 treatments. First is no or zero application of urea. Second, 100% recommended dose of fertilizer. And treatment 3, 50% nitrogen through soil conventional urea, which replaced with 2 sprays of nano urea and 100% phosphorus and potash. So treatment 3 found superior compared to the control and at par with 100% recommended dose of fertilizers in case of plant height, number of internodes, and yield also. That means it shows that we can reduce the 50% application of nitrogen with 2 sprays of nano urea in a sugarcane. This is a 3 years pool data. Then sometimes there are some thought that there may be some nutrient mining or native nitrogen might be used by the plant. So this soil analysis shows that there is no that much nutrient mining. In case of treatment T3, there is little reduction is there, but it is not much as treatment T1. So it shows that there is no any nutrient mining in case of nano fertilizer used in a plot also. So this is regarding the cost. There is one issue regarding the spraying cost. It is correct. We'll incur the cost of around 1,000 rupees per acre. But if you see the income, we have got 11,000 rupees more income compared to the traditional. So that can be covered, that spraying cost can be covered through our income. So in short, nano fertilizers are revolutionary product developed by nanotechnology. It are the controlled slow release fertilizers having coating of nanoparticles. It improves the germination. If nano DAP applied, it improves the germination. Then it increases the all yield attributing and growth attributing characteristics. And the feature of nano fertilizers is depends upon the adoption of these fertilizers by the plant, then some effective legislation and production of novel nano fertilizers as per the need of farmers. Then cooperation of stakeholders is also required to promote the nano fertilizers, and some long-term studies are also required to study the impact of nano fertilizer in soil, water, and plant contagion. So this is a new baby, requires again some long-term study, but to save our soil, water, air, and our foreign exchange in terms of subsidies, these fertilizers, we have to go for this kind of fertilizers only in future. Thank you.
Thank you, Mr. Pawar. We can take up 2-3 questions. If anybody is interested, please give the mic.
Mr. Pawar, thank you for presentation. You have shown new line for using nitrogenous fertilizer. So my one suggestion is, care should be taken, there should be a vast trial in all over India, that is one. And you have to give cost-benefit ratio using urea as a source of nitrogen and this nano urea with percentage. There is 45%, here is 4%. You have to give cost-benefit ratio per hectare. Then you can go for extension activity. That is my suggestion only. That is not included here.
So I have, regarding sugarcane, I have given benefit cost ratio also. In that slide I have given. Benefit cost ratio is given in slide.
This sugar nitrogen is used for almost all crops.
All crops. Yes, sir.
You have to show class-wise. Vegetable, pulses, likewise you have to show.
Yes, sir.
If you have to go, then you have to show likewise. ratio.
Yes, sir. What, because this is a sugarcane symposium I have taken for
That is
sugarcane.
okay. That is
Yes,
okay.
sir. Yes, sir.
That is okay. But you have to show, now you are going extension level.
Yes, sir. Yes, sir.
Okay, thank you.
Thank you, sir. Thank you.
सर आपण ट्रीटमेंट प्लांटसाठी वॉटरला DAP आणि युरिया वापरतो. ह्यूज अमाऊंट असतं ते. तर तुमचं नॅनोचं वापरलं तर प्राइस कमी होईल का? आणि ते किती वापरावं? ॲज अ मायक्रो न्यूट्रिएंट म्हणून.
ट्रीटमेंट प्लांटला
येस.
म्हणजे तुम्ही कारखान्यातलं बोलताय का?
हो, इफ्लुएंट ट्रीटमेंट प्लांटला आम्ही DAP आणि
नाही मॅडम, तसा काही स्टडी नाही आहे, आपल्याला बघावं लागेल.
हा, तर
कारण का
तसा स्टडी.
आम्ही ॲज अ प्लांट न्यूट्रिएंट म्हणून त्याच्याकडे आता बघतोय.
अच्छा.
पण इंडस्ट्रियल यूज मध्ये आपण काय त्याचं अजून तेवढं
सर
बघितलं
तो केला तर तो
ठीक आहे.
डेफिनेटली,
तसं आपण
साधारण 10 टन आम्हाला लागतं युरिया
ठीक आहे, ठीक
आणि
आहे.
10 टन DAP. जर तुम्ही नॅनोचं
नाही, चांगलं
रिलेटेड केला तर.
तुम्ही चांगला ऑप्शन दिलाय, आपण ते पण बघू मग.
येस सर.
ठीक आहे, थँक्यू.
सर नमस्कार.
नमस्ते.
नॅनो युरिया व नॅनो DAP तुम्ही जे फॉलियर स्प्रेला रिकमेंडेशन केलेलं आहे, तर ते रिकमेंडेशन ड्रोन स्प्रेला पण सेम राहील का? कारण याच्यामध्ये कुठे उल्लेख आला नाही.
बरोबर आहे. ड्रोन आपला जो डोस आहे, जो आता मी 500 ml जो सांगितला तुम्हाला पर एकर, तोच आपण ड्रोन मध्ये सुद्धा तोच आपण हे केलेलं, रिकमेंड केलेलं आहे.
75% यूज करावा असं काही
नाही
लोक सांगत आहेत.
नाही, कारण काय एकरचा जो डोस आहे तो डोस आपल्याला द्यायचा आहे. पाणी फक्त कमी लागेल, बाकी डोस आपल्याला तेवढाच द्यायचं आहे.
अच्छा, 25% कमी करायचं
नाही, काय गरज नाही. कारण काय मुळातच आपलं प्रमाणच कमी आहे.
थँक्यू.
सर नमस्कार.
हा नमस्ते.
आपला जो नॅनो युरिया आहे तो आपल्या रेग्युलर युरियाला म्हणजे कम्प्लीट 100% रिप्लेस करू शकतो का?
नाही, आपण 100% रिप्लेसमेंट आपण म्हणजे सांगितलेलंच नाही. आपण जे आतापर्यंत ट्रायल घेतलेले आहेत ते आपण 50% रिप्लेसमेंट पर्यंतच बघितलेले आहेत. कारण का ह्याचं जे ऍप्लिकेशन आहे ते फोलियर आहे. त्यामुळं आपल्याला सुरुवातीला जो बेसल डोस आहे तो द्यावाच लागेल, जेणेकरून पिकाला चांगल्या पद्धतीचं पानं किंवा फोलेज येईल आणि त्यानंतर आपण त्याच्यावरती स्प्रे घेऊ. म्हणजे नंतरचा जो आपण दुसरा डोस तिसरा डोस देतो तो आपण याच्यामध्ये नॅनो युरियाच्या साहाय्याने आपण रिप्लेस करू शकतो.
ड्रेंचिंग वर काही अभ्यास झालाय का?
ड्रेंचिंग वरती अभ्यास अजून नाही आहे, पण आता चालू आहे आमचा अभ्यास. कदाचित येणाऱ्या पुढच्या 1-2 वर्षामध्ये आपण त्याचे रिझल्ट देऊ.
ओके, थँक्यू सर.
थँक्यू.
सर नॅनो युरिया आणि नॅनो DAP हे दोन्ही मिक्स करून फवारणी केली तर चालते का?
चालू शकते, चालू शकते. म्हणजे त्याच्यामध्ये बाकी तुम्ही पेस्टिसाइड पण टाकू शकता. फक्त ते टाकण्याच्या अगोदर एक जार टेस्ट तुम्हाला करायला लागेल. म्हणजे एका ग्लासमध्ये सगळं मिक्स करून जर ते फुटलं नाही तर तुम्ही वापरू शकता.
Thank you, Mr. Pawar,
Thank
for a
you.
nice presentation.
Thank you, sir.
Now I will request Mr. Hegarna from the Datta Sugar Mill to make his presentation.
Good evening to all. Honorable Chairman, Co-Chairman, Honorable Chairman Sahab, Sri Datta Sugar Factory, Honorable Scientists from Dais and Friends. I am Sri Shail Heganna, working as Chief Agriculture Officer in Sri Datta Shetkari Sahakari Sakar Karkhana Limited, Shirod since 2013. And we have factory have a separate wing of cane development and well-established soil testing laboratory to assist the cane development. And from we run various sugarcane projects or to improve the yield as well as the soil, to improve the soil performance or the soil quality. During 2011, we have started with mission 100 per acre of sugarcane, mission 100 metric tons of sugarcane per acre, and then 150 metric tons per acre sugarcane production. And with this project, we have started our cane development schemes, but up to certain limit, after certain time, we got some limitations for the yield. At every stage, we have precisely used the technology. It may be the cultural operations, it may be the fertilizer applications, it may be the pest control, disease control. But the increased height we got some limitations to that. And when we look up to why it is so, when we look back, we focused on 2 points. That is the soil, one is the soil organic carbon, and secondly, the soil health or the soil salinity or waterlogged, prolonged waterlogging conditions of the soil in our area. And initially we decided to work on on soil organic carbon. And from 2011 up till today, it was initially, the soil organic carbon level was on an average, it was 0.3%. And now from last 3 or 4 years, it is stable up to 0.85%. Some farmers have more than 1% soil organic carbon also. And after that, to improve the problematic soils like soil salinity or waterlogged soil, prolonged waterlogging conditions, we have decided to go for the artificial subsurface drainage to improve such soils. It may be saline soil or it may be the waterlogged soils. And selected in our area, we have selected some villages where this problem of waterlogging and soil salinity was severe. And these are some locations where we have implemented such projects on community basis. Where we have implemented the project, where the soil is deep black cotton soil, highly fertile soil with high amount of clay percent and high cation exchange capacity. Along with these soils, we have implemented on both type of soils, that is chemically damaged soils or chemically infertile soils. That means the pH or EC of such soils are beyond the norms, especially the electric conductivity of the soil, which is up to 24-28% electric conductivity was there in such soils. And secondly, the waterlogged soils, that is the physically damaged soils, where the soils or chemical properties of the soils are within the norms. But due to the prolonged waterlogging conditions, weeks together, months together, the waterlogging conditions, you can see in the video, that is the surface ponding is there. After heavy irrigation or after heavy rains, there is a surface ponding is there, or waterlogged conditions prevails months together, due to which the fertile soil becomes non-productive. And under such soil conditions, we have decided to go for the subsurface artificial drainage project with perforated pipes. If we see the extent of the soil degradation at the national level, it is 6.72 million hectares, which is affected with the saline and sodicity. And in Maharashtra, it is 6 lakh hectares. And if you look at the Shirol Tehsil, where the factory is located, out of total cultivable area, that is 36,000 hectares, 10,000 hectare soil is affected with the soil salinity and the waterlogging conditions. From 2015, we started this project with soil reclamation project, and till today, the project is considered as the Datta pattern of soil reclamation project and consists the project 23 villages, and out of what area covered is 3,250 hectares of land with main pipelines of 210 kilometers, and SSD completed area is about 1200 hectares. This area is now, the farmers are growing very well crops in this area. The features of this project, total project, is farmers have invested the total funds which is required for this project. Closed pipeline is the another most important feature of this project, and which is the key for the success of the project. I will explain you why it is the key for. Individual design is provided for 20 guntas also. Farmer, for every field, we have provided the individual design and controlled drain. Controlled drain to maintain the field capacity of the soil or to retain the soil moisture. These are the components. In first picture, we can see the DWC pipe which is used for the main drain, as a main drain. Initially, it was used. The open channels were used to drain out such water from field to the end point. And when we went with the farmers for the subsurface drainage, the farmers told us that open channel was the main constraint while we are going to implementing this project, because the efficiency of main drain to carry the water from field to end point was very low, and the lifetime of the open channel is very short. It remains for only 2 or 3 years. It comes in working. After that, the efficiency goes down. And to overcome this problem, our chairman sir decided to go for the closed pipeline, and we have tested that closed pipeline also for its strength to sustain the load of the soil, because we have put this main pipeline under 20 feet, more than 20 feet depth also. Then that is one RCC inspection chamber is provided for every 10 to 12 acres of land, just to inspect the total system which is running properly or not. And last year, this total system, total drawing and design, total spacing, depth, and drawing and design and implementation, we have got the copyright from the central government of the total area. These are some guidelines given by the Central Soil Salinity Research Institute, Haryana, which is the Apex Institute, which works on the reclamation of such problematic soils. And according to the soil type, light, medium, heavy, and very heavy soils, they have recommended the drainage spacing and drainage depth also. And in our area, we have decided to go for the 50 meter spacing and 1.2 meter depth, and which is working very well in our area. For the research purpose, we have selected 2 different locations, that is one from river Varna Basin and one from the Koyna river Krishna Basin, 2 different rivers which provide irrigation water to our in our area. And soil samples were collected from various depths, that 0 to 30 centimeter, 30 to 60, 60 to 90, and 90 to 120 centimeter, and analyzed for the various chemical properties as well as physical properties. And you can see the impact within 2 years. The soil pH before and after, when we analyze the soil samples before the SSD implementation and after the SSD implementation, there is slight increase in soil pH is observed. It may be due to the easily leaching of the sodium carbonate or sodium sulfate, which are easily soluble in water, rather than the sodium carbonates and bicarbonates. But the increase in pH is very marginal. But if the electric conductivity is compared before and after the SSD treatment, there is a drastic decrease in electric conductivity was observed in both cases, and at every depth, and around about 60 maximum up to 96% decrease. But on an average, we have got 60% decrease in the electric conductivity within 2 months of period. That's accordingly the elements which are responsible for the electric conductivity, that is calcium. That is, in every element, the calcium content also found decreased by to 73%, maximum up to 73%. In second villages, it is 82%, 83% decrease in calcium content. It was also observed. That's likewise the magnesium content in both cases, before and after, it is 66% in Sedshar village and 84% decrease, maximum decrease is observed in magnesium content also. Likewise, sodium content, minimum 50% and maximum 84% decrease in sodium content of the soil is observed within two years period. Well, physical property one we have analyzed for bulk density, and physical property, that is bulk density, also observed reduced by not much extent but up to 6%. The bulk density is also observed reduced within 2 year period. It may be due to the leaching of sodium element from the clay particle. It may be. Secondly, we have one challenge in our area, as I explained earlier, the waterlogging condition or the field maintenance of field capacity. And by using the subsurface perforated pipes and subsurface drainage project, it is possible, even after heavy rain or even after flooding in Krishna River or Varna River, within 2 or 3 days, total standing water, surface standing water gets removed from the field when we start that is the control system, drainage system. This was very important because before implementation of SSD, it requires weeks together to field to come to its field capacity. But after implementation of SSD, within 2-3 days, the field comes to the field capacity, which is more important for the aeration in the soil. That is the drastic change or drastic effect where we have implemented the SSD project. And ultimately, our main aim is the increase in the yield. And we have 4 or 5 farmers were studied before and after implementation. There is 50% more yield within 1 year after 1 year of the implementation of the SSD. And in some cases there is 100% yield improvement is there, because some area was the farmers were not cultivating some area from last 20 to 25 years. Single plant they cannot able to grow the single plant or single crop from last 20 to 25 years. In such area or such field, they are growing various crops, not only sugar crops. They are growing various vegetable crops, flower crops, and all that crops. Some regards to implement this project, where the Institute of Central Soil Salinity Research Institute, VSI, MPKV, we have got their guidance, and under the guidance of all these, we have implemented the project. Some experts visits are there, from VSI to Raichur with MPKV and all that. Conclusion, no doubt this subsurface drainage project or the subsurface drainage system is the proper and 100% assured technology which can improve the soil or which can improve the problematic soils. But such projects should be implemented on community basis. Individual farmer cannot do at all. Drain depth, drain spacing, and grade of the total system on which the total system runs the grade. These 3 points are very, very important for the success of this drainage improvement. And finally, it definitely helps to improve the socio-economic status of the farmers within few days or within 1 year. This technology definitely helps to improve the socio-economic status of the farmer, and definitely this system is going for nation building system. And he is the person, Honorable Chairman, J. Patil, our chairman, he is the person who is looking after the total project. And under the guidance, under the support of his institute, the Datta Sugar has completed the total project. Thank you very much.
We can take up 2-3 questions. Please provide the mic.
Sir, I would like to know the cost of this project if we take a particular area of about 50 hectare and a distance of a drain of 10 kilometer. Then what may be the cost of it?
The total system is divided into 2 parts. One is the main pipeline, which carries the total collected water to the end point, and second one is the internal, actually SSD we implement in the field. The SSD implementation in the field, the cost is more or less same. It comes up to 90,000 to 1,10,000. But the main pipeline cost depends. Where is the starting point, where is the end point, and how much area you are going to incorporate in the total project. It is in our area, it comes from 25,000 to 53,000 for main pipeline.
Sir,
Round about 2.5 to 3 lakhs per hectare.
Including all.
Sorry?
Including all.
Including all.
Okay, thank you.
Okay, thank you.
Thank you, Mr. Heganna, for a nice presentation. Now I will request co-chairman to offer the remarks. No problem. So just I will summarize. There were 2 presentations in this session. First one by IPCO regarding the nano urea. Nano urea is upcoming subject. Some trials are conducted, some trials are underway. To standardize the technologies, since the drone technology is also coming, so some trials are underway at VSI also, and in-depth studies, they are still needed, as suggested by some of the delegates. For wider adoption of the technology, there should be in-depth studies, and these DAP, nano urea, that will be popularized after these studies, and it will be accepted by the farmers. As far as second presentation made by Mr. Heganna, that is the subsurface drainage system. That is the need of the hour. Success story already he presented. The person behind this is Sri Ganpatrauji Patil, who is sitting beside me, by the side of me. He took a lot of efforts, and now at present the area, more than 3,000 hectare area, 3,000 acre area, it is already under subsurface drainage system, and results are encouraging. As correctly pointed out by Mr. Heganna, that is the community efforts are needed. Single farmers, it is not possible to do it. And one of the delegate asked the question regarding the how much is the expenditure. Just at VSI also we are having such a type of project recently. It is underway now. The cost of the system that is coming around in the field as coming, it is around 1 lakh rupees. And cost of the main pipeline, that depends upon the length and where water is to be drained out. Now, earlier project of the subsurface drainage, why it is failed? The water was not drained out to the lowest point. That's why, because of the silting of the nalas or some of the trenches, that is a free flow of the water with the gravitational force was not possible. That's why some of the previous projects they failed. But in this project, that consideration is that last experience it was considered, and water is drained to a lowest point so that there is always a free flow of the water, and whatever the salt accumulated or the water stagnated in the field, that can be efficiently drained out. I also visited that project also so many times. As regards, because now this area is increasing, awareness is created. Now the quality of the material, it also matters for the longevity of the project, or the that pipe that should be lasted for longer period and efficient, that is a drain out of that water and the salt that is possible. For that purpose, ISI standard pipes at least that should be used, minimum standard, so that its durability will be more and it will work for longer period. So this is a very good project. Now, I asked Gandharv Patil to speak, but he told that he's an officer. He presented nicely. So I thank both the speakers for their nice presentation. I also thank the co-chairman also, and also Sri Gandharv Patil. And I declare that this session is over. Thank you very much.